So today, the main topics that we will discuss is how to train the NLP engine. Along with that, we will start off with, testing the performance of the bot, deploying the bot, and monitoring the bot after it has been deployed to the end users. Okay. Before we get started with that, 1 second. Okay, so before we get started with the NLP training part, there are a few more tasks that I have added into this bot, namely 2 tasks, that is open account and make payment. The purpose of the open account task is just to show you all how a task with there can be multiple entities configured within a particular task. Yesterday we had just a single entity. So here, this is a task which will prompt the user for the type of account he wants, the name of the account holder, and the opening balance of the account holder. Now, if I talk to the bot and initiate this particular task, the name of the task is open account. So we just put that. You can see it displays a choice of the type of accounts from where the user can select any one of it. Okay, so there was a question yesterday, how do we display some choices to the user so that the user can select any one of those choices, and when the user selects any one of these, what is actually stored within this entity. Okay, now the type of entity which will allow you to define a list of choices to be displayed to the user is a list of builder. Okay, so the type of the entity is list of items. If I'm not audible or if my voice breaks, please let me know. Okay, so list of items, and once you select this type of an entity, you can click on the set wheel beside the yes. Okay, so you click on the settings wheel over here to define what will be displayed as choices to the user in the conversation window. Now, there are 3 columns over here, like you all can see. Okay, the display name, the value, and the synonyms. Now, what is the requirement of these 3 columns that we have? Display name is how the choice is presented to the user. Okay, so you can have a descriptive text, presented to the user in the conversation window. Like I have savings account and checking account. These are the 2, choices that are presented to the user in the conversation window. Value is the final or the ultimate value that is stored within this entity when the user makes a selection. So if the user clicks on savings account, the ultimate value that gets stored within this entity is savings. Okay, I can keep it as savings account also. But if you feel that what you are displaying to the user is a very descriptive text, but a part of the text is good enough, internally to understand what is the choice of the user, then you may not store the entire value that is displayed to the user within the entity. Okay, so I can either have savings account just as it is defined over here, or I can just have a part of that text like something like savings and checking. This is good enough to tell me internally, like what is the type of account the user wants. Okay, is it clear to you all the purpose of these 2 columns? Any questions on this? Now, coming to the 3rd column, yesterday we have seen that, let's say, let's talk to the bot once. Now, if I say open savings account, okay, so I'm not only specifying the task that I want to perform, but I'm also specifying the type of account I want to open within this particular utterance. Okay, so can the bot pick up this account type from this utterance and not prompt the user once again to select the type of account? Let us see what happens. And you can see it directly skips the account type entity and goes to the next entity, that is the name of the account holder. Okay. And in the debug logs, you can see the account type entity, the value of that is picked up from the utterance. And what is the value? The value of that is savings. So if we directly put an utterance where it does not find an entity value, it will prompt the user for the entity value. But if when an utterance comes from the user, if the NLP engine sees that the entity which is in context, the value of that is present within the utterance of the user, NLP will pick up the value from there, store it within the entity, and skip to the next entity, because this entity is already populated with a value that is extracted from the utterance of the user. So it doesn't re-prompt the user for that, but skips to the next entity and prompts the user for the account holder name. Now let's say, so if I say open a checking account, so if we go over here, if you come to the entities section, you can see account type entity is holding the value of savings, because that is what we had given. And this is the value that is the ultimate value that is allowed for that entity. It matches over here with this value. And the bot has picked it up and stored it within the entity. Now, let me just change my utterance a little bit. Okay, and here I say open checking account. Now, checking is one of the supported values over there in my list of items. So it should be able to pick up the account type from the utterance of the user and store it within the respective entity. There are many a time when a particular value there are many a time when a particular value is, provided in a different way by the user. Something like, in many countries, a checking account can also be referred to as a current account. Okay, so now if the user says, I need to open a current account, okay, what he means is a checking account, but he has said, or he has specified the account type that he wants using a different word. Okay, so instead of saying checking account, he has said current account. Now, does the bot have the intelligence to understand that current account actually means a checking account? Okay, so how do we train the bot to understand that? Okay, that current account and checking account mean the same. So if the user says checking account, then the bot should store checking as the type of account. If the user says current account, then also the bot should have the intelligence to understand that the user wants a checking account. That is what we specify in the synonyms column. The third column that we have is the synonyms column, which lists out all the possible values that the user can provide for this entity. So for the checking account type, the user can either say checking, or the user can specify the same type of account using the word current. So current is a synonym of the word checking. So either the user says checking or the user says current, the actual value that will be stored within this entity is the value that is provided in the second column. So the synonyms column will allow you to improve the intelligence of the bot to handle synonymous ways of presenting the same value in the utterance of the user. You can specify as many synonyms as you want by separating each of the synonyms with a comma. Okay. Is it clear to you all? Remember, it's not essential. Only where it is needed, there you need to specify synonyms. Because see, for savings, I have no synonyms. But for current account, I have, checking account, I have current as a synonym of checking. Okay. Is it clear to you all? Any questions on this, these three columns? Okay, you can define as many items as you want within the list. And once you have defined your list, then comes the user prompt, of course. So you provide the prompt, which will be displayed to the user in the conversation window above this particular list. You can once again add multiple user prompts, and any one of it will be picked up randomly when the user is talking to the bot and user is talking to the bot. Remember to enable the display of the list of values. Okay, just like the confirmation note, where by default that yes, no choice is not presented to the user. though the the bot expects the input or the response of the user to be yes or no for a confirmation node. In the same way, if you want to display this list of values that you have defined in the conversation window, enable the display of the list of values. The default is do not display the list of values to the end user. Okay, so that is the first entity that I have configured, a very important, a very common type of entity that we use, that is a list of items. The second entity is a name of a person. So once again, it is person name type of an entity. Okay, and the third one is a balance, the opening balance, which is again a number. Now, yesterday we have seen one validation on a numeric type of input, or any kind of, that type of a customized validation, that it has to be a combination of 10 digits, or the account number has to start with 2 letters followed by 8 digits, something like that, which we can do through a custom entity and then define a regular expression, a JavaScript supported regular expression to validate the input coming from the user. But beyond this also, at times we need to implement some business rules to validate the input that is coming from the user. Like, let's say you want to implement a business rule over here, that the balance that the user provides, if the account type is savings, then the opening balance has to be a minimum $1,000. Okay, so it cannot be less than $1,000. Okay, similarly, if the account type selected by the user is checking, then the minimum opening balance has to be $500. So this is an additional business rule. Okay, balance is number, that is fine, but on top of that we are implementing an additional business rule, okay, to validate the input that is coming from the user. How do you do things like this? And this is a very simple, it can be done with if else conditions, but when you're going ahead, when you're working on very complex conversation flows, you might need to go in for a lot of complex validations, like date validation, comparison between 2 days received from the user, calculating the number of days between 2 dates that the user has entered, things like that. How do you do these kind of how do you do these kind of codings or implement these kind of logics within your conversation flows? So once again, this has to be done through a script node where you can write a JavaScript in order to implement these rules or these logics. So here what I have done is, though I could have done it with a logic node, or I could have done it simply directly through the connections property of this particular node, but I have used a script node over here to show you all how we can do it. So here you can see the JavaScript that I have written. So I'm checking for the account type. Remember, no double curly braces over here when you are referring to an entity or an API response within the JavaScript. The double curly braces around entity names or around components returned in an API call, or around the form components, are required in the message nodes, in the entity prompts, in the confirmation nodes, and in API, that is service nodes. Okay, in any other place, like if you are checking for some entity value or something in the connections property of any of the node, or you're referring to some entity or some component returned by an API call within the JavaScript, you do not need the double curly braces. Okay, so you can see context.entities.account type, if it is equal to savings, and if the balance is greater than equal to 1,000, then it is acceptable. Okay, my validation works. Else, if I'm checking whether it is checking and the balance is greater than equal to 500, then also it is perfect. Otherwise, I'm going to display an error message. Okay, so either I go ahead with a service call where I add the details captured from the user into my table using an API, or I display an error message to the user that you have provided an incorrect balance or something like that. Now, from our yesterday's discussion, we know that how can we define this alternate rules? we can define this alternate flows from the connections property of any node. Okay, we can put those if conditions, or else if conditions, multiple level if else if conditions to define this alternate flows from a particular given node. So that means, though I'm checking for the condition over here within the JavaScript, my alternate flows will be defined from the connections property of this particular node, of the script node. So it is not from within the script itself that I can say what is the next node that should be executed depending on which rule works. Okay. So how do we typically do? We have some variable defined. We change the value of that variable, check for the variable value in the connections property, and define our flows. I have a variable over here called next node. Okay. The way we define a variable is var followed by x. That is the default way in which we define variables in JavaScript. Okay. Now this variable, the scope of this variable is only restricted to this particular script, which means once the script comes to an end, this variable x is no longer available. So you cannot use this variable x in the connections property of this particular node to define the alternate flows. So whatever variable you need, okay, has to be a variable which is accessible outside the script in which it is defined. How do you create variables like that? Something like global variables, which can be used outside the script where it has been defined. You add the variable into the context. This is a very important thing to understand. Typically for developers who are going to work with JavaScript, if you are into bot building and complex flows and all, where you will be using JavaScripts and all, you will see many a time you need to calculate something, store it into a variable, but that variable is required outside the script node. Okay. Maybe in adding details into a table, or you're going to do something else with that calculated value. So you need to access that variable outside the script where it is defined. How do you do that? You add the variable into the context. Okay, and the way to do that is context dot the name of the variable. The name of the variable can be anything. The moment you say context.name of the variable, this variable is accessible outside the script where it is defined, and this variable is available till the end of the dialog task. Only when the dialog task comes to an end, this variable is no longer available. Okay, is it clear to you all why we are defining the variable in this way? And finally, what I have done is, you can see, sorry, I came out of that node. From the connections property of this node, I'm seeing that if the next node variable, which I have defined in the context within the script, within the JavaScript, if it is equal to true, then I go to the service call. Else, if it is not equal to true, that means it is false, then I go to a message node through which we display an error message. Okay, so if you come out over here, let me just quickly show you all the configuration of the service call. Okay, this is a post API call. Yesterday we have seen a get API call. We have seen add data service call for a data table. But how do we add data into a table using an API? Of course, it is through a post API call that you add data into a table. So that's what I have done over here. If you look into the same configuration of this API, you can see it is a post call. Since it is a post call, there has to be a body of the request. Okay, you can select how you're going to define this body. I prefer JSON. If you want to go in for an XML format, or you want to go in for a form kind of a way of defining the input or the body, you can select any one of it. Okay, the form will show you two columns. The left hand side should be the name of the column in the table. The right hand side will be the parameter you want to pass for that particular column. Okay, so here in JSON within double curly braces on the left hand side is the name of the column from the table. This should match exactly with the way the column has been named in the table. Okay, on the right hand side within double curly braces you have the entity which should be passed for this particular, the value of which should be passed for this particular column. If you are capturing details in a form, then it should be context.forms.name of the form .name of the component of the form. So there's no restriction that with a post API call, you should only use entities, nothing like that. If you're capturing the input, in a form, just like yesterday, we have seen that we can add those details into a data table. In the same way, the form component details can be passed as parameters with a post API call also. So here within double curly braces, it should be context.forms.name of the form .name of the component of that form. Okay, that's all you need to do. Is it clear to you all? Any questions over here? Okay. For all of y'all who are not good with JavaScript and all, it should not be full showstopper, okay, for multi-level if, else, if conditions and all. If you're not comfortable with this particular script, okay, though many a time you will need JavaScript if you're doing some complex validations and all, but if it is just multi-level if, else, if conditions where you are checking for values of combined entities, multiple entities together and defining the flows, and you don't want to go in for JavaScript, in that case, we have a different type of node. Let me just quickly show it to you all, which is called a logic node. Okay, so you can also use a logic node to define that. Create a new logic node. Now within this logic node, you can provide the name of the logic node of course, and come to the connections property. Here add if condition. Okay, and you can see you can define and or. Okay, so if I say over here something like context dot entity, see I'm not using the double curly braces over here, account type. Okay, if it equals to, see the way the same thing that I had written in the script node, I'm doing it in the logic node, is equal to savings and, okay, context dot entities dot balance is greater than equals to 1000. Okay, then what do we want to do? We want to go ahead with saving the details. Okay, so I connect to that particular node, that is the save details node. Okay, else if I can add the second condition where I say if context dot entities dot account type is equal to checking and context.entities.balance is greater than equal to 500, then we go to the same path. Okay, and the final else will be the message node where we display the error message to the user. So if it is just with if, else, if conditions and all, you can go in for the logic node. It's particularly for people who are not comfortable with JavaScripts, but this is all you can do within the logic node. But if you want some calculations, some other logic to be implemented on the input captured from the user before you define these flows, then of course you need to use the JavaScript. Is it clear to you all the purpose of logic nodes? Any question on this? I'm just removing this. Okay, and there is another one. One second. There's another task that I have created. Purely, I'm going to use it for the purpose of NLP training, and that is a make payment task. There are just two entities within this. One is the account ID. I have reused the account ID entity, which I had defined yesterday, how you can reuse any of the nodes which are defined within this project, okay, in any other task. You will see whenever you come to a particular type of node, you can see the option to create that new type of node, and you get the list of existing nodes which has been already defined, maybe in the same task or in some other task. So you can just select on any one of these nodes whose instance you want to create in this particular task. So that is how I had done it. I went to entity and I just selected this account ID entity. It created a new instance of the account ID entity. A very interesting thing with the entity node is that when you create an instance of an entity node in some other task, you can see it has been created with the default prompts that we had defined yesterday, okay, for the check balance task. But maybe I would need to change this prompt for this instance of the entity. Okay, that is for the account ID entity within the make payment task. Okay, how do we do it? I'm not going to remove these because these prompts are used in the check balance task. What I do is I come to the settings button over here and I say override for this instance. Okay, so I just enable this and I provide the prompt which will be used for this entity only within the make payment task. Okay, so I just come here and I say okay, so this is something you can do only with the entity nodes, remember, and this is this and the error prompt you can override for a given instance of an entity, but you cannot change the name of the entity, the display name, or the type of the entity. This remains same across all the instances of a given node, okay, any node, okay. So name and display name across all the instances. For an entity node, the type will also remain same. So you cannot have different types of entity with the same name across different tasks. Okay, is it clear to you all what we did right now? Okay, now let us start off with the NLP training part. And yesterday we have seen that since we have not trained the NLP engine, we had to ensure that to initiate the dialogue tasks, I was using the name of the dialogue task in my conversation. As long as the words which are present within the dialogue task are present in the utterance of the user, NLP engine was able to qualify the task. Okay, so maybe I just say check balance, or I say I need to check my account balance, or I need to say, can you check the balance for me? As long as those two words which are used in the task name, that is check and balance, are found in the utterance of the user, the NLP engine can qualify the task. But that should not be the only way in which we go in for intent identification. Because here, the moment we say that we have built a conversational bot which supports natural language, we have to first understand that in a natural language, the end user can ask for a task in multiple different ways. So we have to train the bot to understand all of those inputs coming from the user and qualify the tasks correctly. Now, when I say task, I don't only mean dialogue task. I mean dialogue tasks. I mean FAQs. I mean small talk if required. So these are different types of tasks or intents configured within the bot. And the NLP should be trained enough to handle the variations in the utterance of the user. Now, how do we train NLP to do that? We have a multi-pronged approach for NLP where we have the machine learning engine, which can be trained with training utterances to qualify dialogue tasks. Okay, so that should always be your first approach and the most important approach to train the machine learning engine to qualify dialogue tasks. And how do you train the machine learning engine? You train it with training utterances. Okay, what are training utterances? Possible utterances that can come from the user when they want to perform a task. Okay, we also have another engine called the fundamental meaning engine, which also can be trained to qualify dialogue tasks. And we use the fundamental meaning engine only in situations where the machine learning engine is not able to handle the utterance of the user. There are certain specific use cases where it may not be a good idea to train the machine learning engine, which we will discuss in today's training session. And in those situations, we can train the fundamental meaning engine primarily with patterns to qualify the dialogue tasks which has been configured within the bot. And the third engine that we have is the knowledge graph engine, which can be trained with the ontology, which is a hierarchical structure of key terms identified from the FAQs that are added into the bot. And once we build the ontology, we can train it further with synonyms of those terms, with term usage, with alternate questions like we have seen yesterday, tags at the question level, patterns to qualify the alternate questions, and so on. All the three engines get into work. Okay, so using their training, they try to qualify the intents which are configured within the bot. Now, each engine, there can be three outputs. Okay, a task can be qualified as a definitive match by any of the engines. A task can be qualified as a possible match when the engine is not very sure, but there is a similarity between the training and the utterance that has come from the user, due to which the task got qualified as a possible match by that particular engine. Or a task can be eliminated if there is no similarity between the training and the utterance coming from the user. Now, if it is a definitive match or if it is a possible match, okay, all of these qualified tasks are sent to a fourth engine called the ranking and the resolver engine, which declares the winning intent. So if the ranking and the resolver engine sees that a particular task has been qualified as a definitive match by any one of these engines, there might be multiple tasks which are getting qualified as possible matches also, but it is the definitive match that is declared as the winning intent. If multiple tasks are qualified as definitive match due to the training that we have provided, then the ranking and the resolver engine declares all those tasks as a winning intent, and a choice is presented to the user, and the user is allowed to select the task he wants to continue with. And finally, if there is one single possible match, then it is declared as a winning intent. And if there are multiple possible matches, then the ranking and the resolver engine rescores those choices and picks up the winning intent after rescoring it. Let us see how each of these engines first can be trained. And finally, we will look into the ranking and the resolver engine. Okay. So let's get started with the training, and whatever I've said right now, we will see it gradually as we continue. So coming to the training section, so we have all the tasks over here. Coming to the training section, we will start off with the training of the machine learning engine, and the machine learning engine can be trained with training utterances. How do we add utterances? You can see all your tasks over here. Okay, so for a given task, when you want to add utterances, come to this utterance section and add your utterance over here. Okay, so let's say the user can say, how much money do I have? Okay, now that is also a task that should go, that is also an utterance that should go and qualify the check balance task. The best approach is, list out all the possible utterances. The more utterances you have, the better is the training of the ML engine. So though it takes effort, but put in this effort, because this should always be your first approach to training. And it's a very good training because ML learns by experience. As you keep training it, you will see ML will learn the importance of the words, because multiple utterances using the same words again and again, you will see ML will gradually, build that intelligence that if it sees those words anywhere in the utterance of the user, it will qualify the task correctly. So keep on training ML engine with as many utterances as possible in order to qualify a particular task. But there are certain things that you should remember when you are adding utterances. Do not add words. It is advisable, though ML will not display any error. Do not add words which do not tell ML engine anything about the task. Something like, how much money do I have? Now here, what are the keywords? What are the important words over here? Which actually should tell you which is the task the user wants. It is how much money. Do I have doesn't matter. Okay, or does my husband have, or does my brother have? It doesn't matter. Okay, the task is check balance, and how do we understand that? It is from those words, how much money. So those are the key words in the utterance which ML should learn. And once ML learns that, it will know that whenever these words are found in the utterance of the user, the task to be qualified is a check balance task. What I would suggest is build a corpus of as many utterances as possible. Okay, I have a few utterances, but this is not good enough. You should be having in hundreds or thousands utterances. I just have a few utterances where you can see I've picked up the keywords. Okay, people can say, how much balance is remaining in my account, or can you show the remaining balance in my account? The order of the words is not important for the ML engine. As long as these words are found anywhere in the utterance of the user, ML engine can qualify this task. Okay. Enough money. Do I have enough money in my account? Do I have enough money to go on a vacation? So as long as these words are found, the task to be qualified is check balance. It does not matter whether the user wants to go for a vacation. He just wants to check his account balance. He wants to buy certain things. It doesn't matter. When he has used the words enough money, it means the task to be qualified is the check balance task. So find out the keywords in the training utterances. And once you have those keywords, then what you can do is you can add them as training utterances for your ML engine. How do you do that? Type in your utterance over here. Okay, press and enter to add the utterance. Yes, yes. So if you say check balance and you say balance check, it's a very good question actually. If I say check balance or I say balance check, it means the same. That's the power of the ML engine. You don't have to bother about the order of the words, where the words are found, the position of the words, nothing like that. As long as ML knows that these words are important, if it finds those words anywhere, it will qualify the task. And it learns as you keep on adding utterances. There will be, of course, for the check balance task, you are going to have multiple utterances using the word balance, using the word money, using the word cash. These are common words, So as you keep on adding utterances, you will see ML will automatically learn the importance of those words. And if those words are found in the utterance of the user, maybe rest of the utterance you have not trained, but those keywords which it has learned is important. If it is found in the utterance of the user, ML will automatically qualify this task. Okay. So if I say balance check, sorry. Okay, so you can see the check balance task is qualified. So the order of the words is not very important. Okay, so how much money? Okay, so let us add a few more things. Okay, instead of directly now going in for training the ML engine, let me just add a few more things here. Sorry. So you can list out all your possible utterances. And remember, again, I'm repeating, this will take time. ML engine training the training the NLP as such. Okay, it takes time. Okay, so you need to understand the utterances. What are the possibilities? Okay, at times we need to take help from our colleagues, from language experts to understand the variations in the utterance of the user. All of these things has to be considered. Build a corpus of possible utterances And once you have a corpus of that, either you can add your utterances by one like this, or you can have a CSV file where you have 2 columns inside it. First column is the name of the task. Second column is the utterance that you want to add. Define as many utterances as possible within that particular file. And once you have done that, import that file within the bot. I'll show you all from where to import it, but import the file within the bot. Okay, now once you have added all the utterances, then what you can do is click on the train button to trigger the training of the ML engine. The training takes a little time because internally it builds the model using which the ML engine will qualify the tasks when utterance comes from the user. So we have to wait for some time. Okay, so the training is complete. I'll show it to you. So now if I say, how much money, let's say, do I have? Okay. So you can see the check balance task has been qualified, where the words check and balance is not present in the utterance of the user. Okay, so the words which are used in a task name are usually known as label words. Okay, so these label words are not present in the utterance of the user, but since we have trained the ML engine, ML now knows that if these words are there, which are present in the utterance or training utterance, if these words are found in the user utterance, then the task to be qualified is the check balance task. How can you understand it is done by the ML engine? Come to the NL analysis section. And within the NL analysis section, you can see a section called the ML, and you can see the task check balance has been qualified by the ML engine as a definitive match. Why a definitive match? Because all the words of the training utterance are found in the utterance of the user. So ML is very confident that this is the task the user wants to perform. You can see the similarity score over here. There is an internal calculation, but you can understand from here, the score is 99% similarity. There are some words which are not there, that is fine, but all those 3 important keywords are there in the utterance of the user. So ML is confident that this is the task the user wants to perform. So the task is qualified as a definitive match, but it is still not the winning intent. Now, who declares the winning intent? If you come down over here, you can see the working of the FM engine. You can see the working of the KG engine, okay? And finally, the ranking and the resolver engine. And where if you scroll down, you will see here the winning intent section, and it is the task which got qualified as a definitive match by the ML engine. So whenever a task is qualified as a definitive match, the ranking and the resolver engine will always declare that task as a winning intent. Okay. Is it clear to you all the first utterance that we are using and how the ML engine is actually declaring that as a definitive match? Yeah. It is the same, but remember, if you're enabling another language, do I show it to you all in the advanced training? But since you're asking me this, you have to do the ML training, okay? So you have to add utterances with keywords in that language to qualify a task. ML will work across all the languages, okay? So all our NLP engine work across all the languages. It is not specific to a given language, okay? Now, let me just change my utterance a little bit. So I say, do I have money? Okay. Let us see whether task is getting qualified or not. I have not added any utterance like this. My training utterances are what? These are my training utterances. Okay. But there are 2 utterances where the word money is there. Okay. So let us see if I say, do I have money? Does the ML engine qualify task or not? you can see the check balance task has been qualified. Okay, so this is the power of the ML engine. It's a very versatile engine. You don't have to think about individual possibilities. Try to think of the common words, okay, the important words which can be present in the user's utterance when they want to perform a task. Yes, of course, I admit that it is difficult to come back with all the possibilities, but there you need to put in an effort, work as a team, gather utterances from your colleagues or language experts and all, pick up those important words, train ML engine. But once it is done, ML engine, if those words are found anywhere in the user's utterance, you can see the task is getting qualified. Though the qualification, the confidence might be a little low, you can see it is a possible match this time, because none of the utterances has matched exactly. That is, all the words have not been found, but still there with the utterance of the user, okay, and the word money is repeated across multiple utterances. So ML means that it is important that the word money, if found in the utterance of the user, should be used to qualify this particular task. So that is why this task got qualified by the ML engine. I'll come to these ambiguities. These are known as ambiguities where multiple tasks are getting qualified. Okay, it's the ranking and the resolver engine which will finally declare the winning intent. Okay. So this is how you can train the ML engine. Till here, whatever we have discussed, is it clear? Okay. I'll take up all of those cases. Okay. So what happens is that, okay, I'll come to this particular part a little later, okay, like how can you handle spelling mistakes and all with respect to this thing, with respect to label words. These are label words, so you can handle spelling mistakes, you can handle acronyms, you can handle abbreviations. Typically, we do it through synonyms. And how do you do that? Also, if in the ML utterances that you are adding, if these words, the possible spelling mistakes of these words, like people can misspell, sufficient and all. Once again, we have to do it through synonyms. Okay, I'll show you all how to define synonyms also. Okay. Coming out of this task, let me just add a few utterances for the open account task. Okay. So I add an utterance like this. I keep using the. Okay. So the user says, I need to keep, $1,000 in a bank account or in a new account. Okay. Or I can say new bank account. Okay. I remove the in. Okay, so keep $1,000 in new bank account or something like that. Okay, so we have seen that even if all the words are not present, still ML can qualify this particular task. But if I add this particular utterance, many a time you have utterances where there might be possible entity values. Okay, now there is an entity balance which is present within the task open account, and this 1,000 is actually a value of that particular entity. Okay, so when the task is in execution and when the balance entity comes into the context, then the NLP engine will look into the utterance which came from the user and see if there are any values present within the utterance of the user that matches with the type of the entity. And when it sees that, okay, balance is a number, and here we have a numeric value that is 1,000. It can be 1,000, it can be 2,000, it can be 500, whatever. Okay, as long as it is a number which is found in the utterance of the user, it will pick up that value from the utterance and store it within the entity. This is the default extraction logic. We will look into this a little later and how we can change this also. Okay, but that is the default extraction logic. Now, it is all fine with the extraction logic that this value or whatever numeric value is found in this position will be picked up by the NLP engine and stored within the balance entity. But the disadvantage here is that we have seen ML works with similarity. So I had used two utterances just now, for example, where in one utterance, all the words of a training utterance were present in the user utterance, where we saw the confidence of ML was very high. Okay, it qualified the task as a definite match. The moment the number of words which are common with the training utterance is coming down, though ML is qualifying the task, but the confidence is gradually going down. Okay, so you can see, do I have money? One word is found. ML is quite sure that this might be the task, but it is not confident. Okay. Now there can be utterances, okay, training utterances that you are adding, where you might have multiple entity values. Okay. The entities that you are configured for your bot, there can be multiple entity values present within the utterance. Now, the thing is that today somebody can say, I need to keep $1,000 in a bank account or in a new account, whatever. Okay. So it matches exactly. The value 1,000 matches exactly with this particular training utterance, and ML will be very confident. Now, let's say somebody says, I want to keep, $5,000 in a bank account. Or somebody says, I want to open a new account with $1,500. This value can change from person to person. We cannot say it will always be 1,000. Okay, it depends on a user how much money he wants to keep in the bank. So this, since it is an entity value, it can change in the utterances. How do we tell ML that what you see over here is actually an entity value? Do not use for giving the confidence score for this particular intent. Do not consider the value present in this position in the user's utterance for the confidence score of this particular intent. How do we do that? Once you add this particular utterance, you highlight the value, you highlight that particular value, okay? Double click on that value. It should come back. I don't know why it is not coming back. 1 second. It will list out the names of, okay, I didn't add it. We first need to add that particular utterance. Okay, so just press and enter and add that utterance. Once you do that, just highlight it over here. Okay, and you can see our platform comes back with a suggestion of the list of entities which has been configured in this particular task. So we have seen right now that the open account task has 3 entities, that is the account type, the name of the account holder, and the balance. Now, whatever comes in this position, whatever number comes in this position is a possible value for the entity balance. If ML knows that this position is for the balance entity, it will not use whatever comes in that particular position to calculate the similarity score for this particular task. So that will give a better scoring for the ML engine. Okay, so what we do is we tag it with this entity. Okay, for one single entity value in an utterance, it may not make much of a difference, but you can have utterances like this, new savings account with, let's say, $500 for, and you put a name over here. Okay, now you can see a lot of words over here within this particular training utterance is actually entity values. Okay, so if there is a change, you will see gradually the confidence level of ML is coming down. Okay, because the words are not matching with the training utterance. How do you train ML to understand that these should not be considered when you are scoring the intent? Once you add the utterance, double click on it and tag it with the respective entity. Okay, so tag it with the respective entity. This will help ML to understand the other words which are not tagged, the similarity between those words and the utterance of the user should be used to score that particular intent. Okay, so that will improve the confidence of the ML engine. This approach is known as NER tagging or named entity recognition tagging. Okay, why named entity? These are entities which are already created. That is why named entity recognition. ML engine learns to recognize those entity values in the training utterances, and if the user's utterance matches with that particular training utterance. It's a very good approach. If you don't do it, ML will not stop over there, not stop in qualifying that intent, but the confidence level of ML might come down. Okay, is it clear to you all why we are using the NER tagging and how to do it? Okay, once you do that, click on the train button. A system entity person name. Person name is the entity type. It's not a system entity, it is the entity type. Okay, named entity you can do, not system entity. If there are some, you do not have any system. From where did you get the system entity? Let me just see. If you're talking about the type of the entity, I have selected the type of the entity as person name. If you're talking about this is the entity type. It is not system entity. This is entity type, which ensures that the input of this particular entity should be, a noun, a proper noun. Okay, that is all that it checks for. So it validates the input of the user. So this is the entity type. Okay. Yeah.
Jayanti, I have a question here.
Please go ahead.
So, if you take the dialog of what we have there also like system entity and user defined entity. So, so whether we have like that here or it is a.
See, this is for named entities which you are creating in your dialog task. Okay, so this NER tagging is always possible with entities which are defined within your dialog tasks. Okay, within our bot, I have not seen any way in which we can create a system entity. I need to find that out. I have not worked with system entities right now. There might be something called system entities, or there might be some entities which are defined globally by the platform which you can use. That might be possible, but as I have not worked with that, so I cannot tell you anything about that. But named entity recognition will only allow you to tag with entities which are defined within that particular task. Because you can see whenever we highlight some value, it comes back with a suggestion of the possible entities. And those are entities which are defined in that task only. It does not suggest you entities which are created in some other task. It does not come back with the suggestion of account ID. It does not come back with the suggestion of the entity payment amount. It does not allow you that. Okay, so only the entities which are used in this particular task that you can use to do the NER tagging for utterances defined for this task. Okay, nowhere, not other entities which are defined in some other task. Clear?
Yeah.
Okay. Now, once you have done the training, once you add all these things, keep on adding as many utterances as possible. Remember, this is the best training that you can give. It's a very good way of training the NLP engine to qualify dialogue tasks. Keep certain things in mind, that is, add as many utterances as possible for each of the tasks qualified within your bot. If there are entity values in your utterance, do the NER tagging. It will improve the confidence of your ML engine. At times we have very overlapping kind of tasks which are very close, okay, similar tasks where the utterances can be very similar. Okay, they can be common words for utterances which are used in different tasks. Give a very balanced training in that case. That means both the tasks should have utterances which use those common words, okay, along with other words which will uniquely tell the ML engine which task to qualify. Okay, something like how much money do I have, okay, or enough money. These tell the ML engine to qualify the check balance task. Whereas if I say save my money, okay, or keep my money. Now here also I'm using the word money, but here the words save or keep should tell the ML engine to qualify the open account task. So this is a balance training where the word money can be used in utterances for check balance, and the word money can be used in utterances for open account. So make sure you add utterances for both of these tasks which are using those common words. Okay, this is one thing to remember. And the next point to remember in the balance training is add similar number of utterances for all the tasks that you have defined within your bot. Okay, so today if you have 10 tasks within your bot, if you train one task with, let's say, 1,000 utterance, and the other tasks you just train them with around 15 to 20 utterances, it's a very skewed way of training ML engine. ML will just look for the similarity, and the task which is trained with a higher number of utterances, ML will always have the probability of finding common words over there, and the chances of that task getting qualified when an utterance comes from the user rises in that case. So provide a very balanced training where every task is trained with a similar number of utterances. So these are certain things you should keep in mind when you're training the ML engine. One of the easiest ways of training the NLP engine to qualify tasks, this should be the approach that you should take. Make a list of all training utterances. If you want to import from a CSV file where you have two columns inside it, first column, the name of the task, second column, the utterance to be added. Add as many utterances as possible within that CSV file. And then finally, you can click on this import utterances and select the file over here. If you want to, export utterances from this bot and import it, so add it somewhere else where you have similar tasks configured, in that case, you can come to export utterances, export in the CSV or the JSON format. Okay, so you can select your preferred format, and that will download a file within your local system with the utterances that you have added in this particular bot. And then after you make some changes, maybe if the task names are different in that particular bot, you can make changes in the task name, okay? Otherwise, you can see the task name and the utterance. Okay, this is how you should be creating your input file. You don't need these two things over there, but these two columns are required, okay? So if you want to change your task name and all, do it, and then you import the file and this file into your destination bot. So all the utterances from this bot will be exported and imported into another bot. Okay, is it clear to you all? Okay. Now, there are certain situations where we say that it can be handled better by another engine that we have, and that engine is known as the fundamental meaning engine. And fundamental meaning engine can again be trained to qualify dialogue tasks. Since yesterday, we have been seeing the working of the fundamental meaning engine, and that we have seen by using the task name. So when I say something like, make payment, okay, or submit details, okay, we have a task called submit details. And since yesterday, we have seen that though we have not trained the NLP engine, providing the name of the task helped the NLP engine to qualify the task. So which NLP engine was doing that? ML was not doing that, because ML will not work as long as you don't add any utterances. So since we have not added any utterances for this task, how was this task getting qualified? Okay, so you can see the task getting qualified over here. If you come to the NL analysis section, you can see ML has not done any qualification. ML, in fact, has not considered the tasks which has not been trained with utterances. I have added utterances for only two tasks. It is showing you these two tasks. There's no similarity between the training utterances and utterance coming from the user. ML has eliminated these tasks. Okay. Then how did this task get qualified? This task got qualified by the fundamental meaning engine. How did fundamental meaning engine qualify the submit details task? You can see the submit details task has been qualified by the fundamental meaning engine as a definitive match. How? If you just scroll down, I'll come to this section. You can see it has qualified the task using the word match algorithm. So fundamental meaning engine works with two algorithms. One is patterns, one is word match algorithm. Word match algorithm comes into play when the fundamental meaning engine qualifies tasks when it finds those label words in the utterance of the user. What are label words? The words which are used in the task name. Okay, so you can see if you come up a little bit where it is showing the task got qualified as a definitive match. You can see in the word match section, it will show you the first word in the utterance of the user matched with the word submit, label word submit, and the second word in the utterance of the user matched with the label word detail. If you come down, you can see in the details section, the input word was submit, the label word, that is the word in the task name, was submit, okay? And the input word, the second input word in the utterance of the user was details, and the label word was details. So using the word match algorithm, both the label words are found in the utterance of the user. The FM engine qualified the task. Let me just change it a little bit. Okay, and I say I need to submit my important account details. Okay, I need to submit my important account details. Once again, the task is getting qualified. Okay, so you can see the submit details task getting qualified. Once again, if you come down over here, ML has qualified check balance as a possible match with a very low score because there might be some words over here which has matched with a part of the training utterances. So if you look into the training utterances, you will find something over there, maybe a small little word here and there which has matched, due to which ML has qualified that particular task. But if you come down over here, you will see it is the FM engine which has qualified the task. Okay, so you can see the fetch, sorry, let me go down to the submit details. Okay, I will come to the other tasks also. Okay, so you can see the submit details task, but this time it got qualified as a possible match, not as a definitive match. Why not as a definitive match? Because this time the total number of words in the utterance of the user has increased a lot. So there are total 8 words, okay, out of which only 2 words are matching with the label word. So FM engine is not very confident, but still the label words are found. That is the 4th word and the 8th word in the user's utterance has matched with the label words. Using the word match algorithm, the task got qualified as a possible match. So it changed from definitive match to possible match because of the ratio between the total number of words present in the utterance of the user, and out of that, how many words are matching with the label words. It's a good algorithm that works, but do not depend on this, okay? Because you can see the confidence keeps coming down. And many a time, incorrect tasks also get qualified because of this particular algorithm. Okay, so you can see over here, even the, the other task, that is, open account task getting qualified. Why did the open account task get qualified? Because there is a one word match over here. The task name is open account. The word account is there, using which the FM engine qualified the open account task. Okay, so though both the words are not present, but still one of the words is found in the utterance of the user. The same is for the fetch details task. Once again, the word fetch is not found in the utterance of the user, but the word details is found in the utterance of the user. Okay, so the task which got a higher score, of course, is where the one where both the words were found, but still the other tasks also got qualified. So do not rely much on this particular algorithm, but still this is a default algorithm that keeps on working for the FM engine, and it always looks for the presence of the legal words in the user's utterance. If you feel that this particular algorithm is hindering your intent identification, it is qualifying intents incorrectly because there are multiple intents which are using common words, and the presence of those words are qualifying all the intents. In that case, you can disable this particular algorithm, the word match algorithm. How do you do that? Come to the thresholds and configuration, and here if you come to the fundamental meaning section, you can see intent detection using task name words. Okay, this means the word match algorithm. If you disable this, then it will not qualify task using the label words. By default, it is always enabled. But this many a time, okay, very commonly we find because of this incorrect tasks are getting qualified. So we would not like this algorithm to work. Okay, we can disable it from here. Is this clear to you all?
Yeah, I have a question, Jayanti. So this feature is like it's like reducing the what to say, reducing the score also. So then why we have this feature, even though
this feature is there? Just think of it. Today you have some task where you have not trained it. Okay, still NLP has some built-in intelligence. Like if this feature is not there, yesterday the first thing I have to do is to not only define task but also keep on training it. Okay, otherwise NLP will never qualify that task, right?
yeah.
Yesterday we have configured so many tasks, okay, and we were qualifying tasks, we were checking the flows and so on. Okay, I did not bother about the NLP training in yesterday's session. So how did I test the flows? Because when you're talking to the bot, NLP has to qualify that task, then only you can test the entire flow. So there is some built-in mechanism, built-in intelligence of the NLP engine through the FM engine, where it looks for those label words. Okay, but if you see by default, this is good. Okay, you don't need to disable it. But many a times you can say, you will see that if there are multiple tasks which are using the same words, if you see that this feature is qualifying incorrect tasks also, then you can come and disable it. But this is a built-in intelligence of NLP. Okay, here you don't need to go and provide the training. This enable means FM engine will always look for those words. One way it is good, but sometimes it can be a hindrance. That is the time you can come and disable it as well. Okay, so I won't say this is something all the time you have to come and disable, but this feature can be disabled if it is not, if it is leading to incorrect intent identification. Clear?
Yeah.
Okay. Now, coming to the other way in which we can train the FM engine to qualify intents is by using patterns. Now, how do we define patterns? Okay, so I'll just use a few use cases where I'll show you all operators that we use to define patterns. But remember, pattern should not be the first approach that you take to train the NLP engine for dialogue task qualification. You should always train ML engine because ML learns by itself. ML can build its own intelligence. ML is more flexible. Okay, so the training that you provide will give you, coverage of rather a huge lot of utterances that can come from users. Okay, that is the power of the ML engine. FM engine patterns are more restrictive. Only utterances which match with that particular pattern will qualify the task. But yes, there are certain situations where we need to use patterns of FM engine. I'll come to those use cases as well. But before coming to the specific use cases, I would show you all, I would discuss certain operators which you need to know when you are defining patterns. Okay. So coming back to the check balance task, I'm going to define a pattern to qualify the check balance task. Okay, So here, you can think of utterances like the user can say check balance, that is fine. The user can say show my balance. The user can say I need to see the balance in my account. The user can say, can you fetch the balance in my account? The user can say, can you retrieve the amount of balance in my account? Something like that. So here, instead of check, the user is using a lot of other words also. Okay, like fetch, show, see, get, display, retrieve, and so on. Okay. Now, either I can add ML utterances. Okay, that is fine. Okay, so I add individual utterances over there. With all of these words. The advantage will be the word balance will become important. So wherever, because it is repeated again and again, ML will learn if the word balance is found anywhere in the user's utterance. It's very important to qualify the check balance task. This importance, this intelligence is all automatically built into the ML engine. But just to discuss different operators of patterns, I'm going to handle this variation using a pattern. So we are going to define a single pattern to handle all of these different utterances. And how do we do it? We open the square brackets where we say check or show or see or fetch. It can be either balance, or the user can say money, or the user can say cash. Okay. Now, what does this particular pattern mean? Okay, this pattern means the utterance of the user can have any one of the words defined in the first list of words. Okay, so within square brackets, the words that is specified separated by a space, it means any one of those words in the given list, followed by any one of the words in the next list of words. So it's a combination of these words. Okay, so it can be show balance or show money or show cash, or fetch balance, fetch money, fetch cash, and so on. Okay, what are the other inherent things this patterns mean? This pattern means it means any number of words before the pattern begins, any number of words after the pattern ends, and maximum 3 words between the words in the pattern. So this is a restriction. Okay, it is not that anywhere those words are found, FM engine can qualify the task. No, it cannot do it. It will qualify the task if these words are found, that is fine, but with a maximum of 3 words. If there are 4 words between these 2 words, then the task qualification will fail. So it is very rule based when you come to patterns of the FM engine. Okay, so maximum 3 words between the words which are defined in the pattern, and the order of the words is very important over here. So one of these words has to come before one of these words. Okay, so now once I have defined a pattern like this, let me just go and talk to the bot and see whether the FM engine is qualifying the task using the pattern. Okay, so I see so can you fetch the cash in my account? So you can see the check balance task has been qualified. And if you come to the NLP analysis section, if you scroll down, you can see the FM engine has qualified the task as a definitive match. How did the check balance task get qualified as a definitive match? If you come down, you can see it has been qualified using a pattern. And this is the pattern which has been used. Now, how did this pattern qualify? Because the word fetch is found in the utterance of the user, which matches with one of the words from the first list, and the word cash is found from the second list of words. There is one word between these 2 words, so all the rules are satisfied. The order of the words is also maintained. The word fetch is coming before the word cash. So since all of these rules are satisfied, through the pattern, the task got qualified as a definitive match. When a pattern matches, it is always a definitive match, okay? But it is very rule oriented. So these are certain challenges for developers. When you're building patterns, you might find it very difficult to come up with patterns. Today, it might look very easy, okay, one single pattern handling so many things. But as you're working with patterns, defining patterns will become challenging because it's very rule-based, okay? All the rules has to be satisfied. Then only the pattern gets qualified. Is the first pattern clear to you? Okay. Let me just change the order of the words. I'll come to why patterns are used, because right now you might think if it is so challenging, then why are we discussing this? But there are specific situations where patterns will help you better than the ML engine. Okay. Now, let us say, I just say I have cash, show it. So you can see intent identification has failed and the bot comes back with a standard response displaying all the tasks it can perform. Why did this happen? Because though the word cache is defined in the second list of words and the word show is there in the first list of words, but the order of the words have changed. So this pattern means the order of the words has to be maintained. Okay, so this pattern does not qualify and FM engine does not qualify the check balance task. So how do we, tell the FM engine that for this pattern, the order of the words is not important. These words can be present in any order. As long as there are maximum 3 words between these words, this pattern should work. I'm editing this pattern by clicking on the edit button. And here I use the next operator, which is the double angular braces. Whatever is enclosed within the double angular braces, whatever words are enclosed within the double angular braces, the order of the words is not important. If you are not using the double angular braces, then a pattern qualifies only if the words are present exactly in that order in the utterance of the user. Okay. So here I'm using the second operator, that is the double angular braces. Now, once we make this particular change, I'm going to repeat the same utterance and let us see whether that pattern helps in qualifying the task. Okay, so you can see the check balance task. Okay, and if you come over here, you can see the FM engine once again qualifying the task as a definitive match and using the pattern. But this time the pattern worked because the order of the words was not important. Okay, is it clear to you all the purpose of the second operator that I have used? Okay, let me just quickly see if there is any. Okay, let me add a pattern for make payment. Okay, I have some patterns ready, so I'm just going to add it. Now this means, oh sorry, I will add one more word over here. This means any one of these words like make, transfer or pay, followed by payment, money, cash or fund, followed by the word account. Now, if these words are found in the user's utterance, the task to be qualified is the make payment task. So once you have defined the pattern, and always remember your training and testing should go together. Okay, don't blindly keep on training without testing and then finally go and test. Okay, don't do that. As you are training, keep on testing, see task intent identification taking place or not. If there is failure, then go back and make change and listen until you get the desired output. Okay, so that should be the approach. So if I say, I say transfer cash from my account, you can see the make payment task getting qualified over here. Okay, because the pattern works. Okay, I guess by now you can understand how that pattern is working. So you can see make payment task getting qualified by the fundamental meaning engine using this pattern. The word transfer is there, the word cash is there, the word account is there. There are 2 words between these 2 words, so maximum 3 words between the words. So 2 words is handled automatically. So the task is getting qualified. But let me just make a small change in this particular utterance where I say transfer cash. Okay. The moment I say this, you can see intent identification has failed. Why? Once again, patterns, like I was saying, is rule-based. Whatever you're defining within patterns, all of those words has to be found in the utterance of the user. Okay. So though I'm specifying, variations in the words, but one of those words has to be there in the utterance of the user. If the words are missing, then the pattern does not work. Okay, so here the word account is defined within the pattern, but the word account is not there in the utterance of the user. That is why this pattern did not work. Now, when you're defining patterns, these are challenges with patterns. If you're working with too many patterns, these are certain things, rules that you have to remember when you're defining patterns. Now, how can I make the word account, optional? This is an important word, I understand, but this word may or may not be there in the utterance of the user. In that case, you can enclose the optional words within the curly braces. Okay, I can also put all of these words within the curly braces. Okay, so any one of these words, because it is within the square brackets, and if I'm enclosing the whole thing within a curly braces, it makes all of these words optional. So one of these words may or may not be present in the utterance of the user. So if you're not using the curly braces, it makes the word mandatory for that pattern to qualify. If there are optional words that you are mentioning within your pattern, make sure that you use the curly braces. So now if I repeat my utterance once again, let us see with the change in the pattern whether the task is getting qualified. So you can see the make payment task getting qualified. And if you come here, you will see the FM engine qualifying the task, but this time using the same pattern where the word account has been made optional. Okay, I'll be sharing a documentation link with you all where all of these patterns are discussed with example. You can refer to that, but once again, I'm repeating, your first approach should be ML training. It's more flexible, it is more easy. Okay, patterns, you have to keep a lot of rules in mind when you are defining patterns. Okay, so I'll be sharing the documentation link, go through it. There are certain places where patterns will be very helpful. Okay. And other than the operators that I'm discussing in the training, there are more operators which can be used when you are defining patterns. Now, the first use case, why should we go in for patterns? Okay, that is to handle single word utterances. Now, what is single word utterances? Let us say the user says pay, or the user says payment, okay, or the user says pay, the user says transfer, okay, nothing before and after it, just a single word in his utterance. He has said payment and pressed an enter. Does the bot have the intelligence to understand the user is asking for the make payment task? Okay, the word payment coming all by itself without anything before and after it should qualify the make payment task. Okay, this can be done with a pattern, because if I add payment as an ML utterance, okay, so I add an utterance where I just put a single word payment for the make payment task. What does ML engine learn? ML engine learns the word payment is to be used to qualify the make payment task. So if the word payment is found anywhere in the user's utterance, the confidence will be very high. There is a single word utterance, and that single word is found in the utterance of the user. ML will be very confident this is the task the user wants to perform. You can say in this case it is right, because make payment task should be qualified. What about an utterance like this, where the user says something like, is my last payment updated in my account? Does the word payment over here, presence of the word payment over here, should lead to the make payment task? No. This utterance is not for the make payment task. The best task that can get qualified here is the check balance task, right? Because if the user looks at his balance, he can understand whether his last payment amount was updated over there or not. So here, when the word payment is coming along with the word updated, it should be used to qualify another task. Okay. But if the word payment comes all by itself, then it should be used to qualify the make payment task. Making this fine distinction is very difficult for the ML engine. Because if you add payment as a single word training utterance for the ML engine, this particular utterance will also lead the ML engine to qualify the make payment task with a very high confidence, because a single word is there in a training utterance, that single word is there in the utterance of the user. ML will be confident that the make payment is the task. Okay, maybe you have added an utterance like this in check balance task, you will get an ambiguity. ML qualifying both the tasks as a definitive match. Okay, because the training utterances have matched. So for these kind of situations, how do you resolve the ambiguity? You should try to avoid ambiguity where multiple tasks are getting qualified. So the best way to handle these kind of situations is through a pattern. Now, how do we define patterns for single word utterances like this? Is the use case clear to you all? Any questions on that? Now, coming back to my bot, I come to the make payment task, I come to patterns, and here within within an angular braces, double angular braces is for an unordered list of words. Within a single angular braces, I'm going to define the single words that should lead to the qualification of this task. Okay, this means the word payment all by itself, nothing before it, nothing after it. Okay, when you enclose a word within the less than greater than sign, it means nothing before these words, this, nothing after this. Okay, same way you can do the other words also. I can say pay or transfer, because I'm putting it within the square brackets, which means any one of these words, but the words all by itself, nothing other than that. Okay, so this is the way to handle single word utterances through patterns. Whereas for the check balance task, what I do is I define a pattern where I say the word payment, if it is followed by update or reflect, let's say if the user says, is my payment reflected in my account balance, something like that. So updated or reflected, you can think about other synonymous words also. So reflect. So if the word payment is followed by any one of these words, then the task to be qualified is the check balance task. This distinction is not possible for the ML engine. ML will qualify both the tasks as definitive matchmaking. Okay, so this kind of situations where you have single word utterances coming can be handled very efficiently through patterns, and that is why we have patterns for the FM engine to handle these specific use cases. Okay, let us see the working of these patterns. So I just say payment all by itself. Okay, the make payment task you can see here. FM engine qualified make payment task as a definitive match. Okay, so you can see the word match algorithm also working. Okay, we do not stop anything. So one of the words has matched with the label word, that is fine. But finally, the task got qualified as a definitive match using a pattern. Pattern gets the highest precedence for the FM engine. Okay, so and the pattern was the payment word all by itself, because it is enclosed within the less than greater than sign. Whereas now discard is an internal developer's command where you just discard the task that got initiated. So here, if I say it's my payment, something like this. So if you come to the debug logs, you will see the check balance task getting qualified. Okay, though the word payment is here also, But if you come to the NL analysis section, you will see FM engine has very cleverly this time qualified the check balance task as a definitive match. How? Using the pattern. Okay, so here the word payment was followed by the word updated. Okay, so this is the first use case, a very important use case where you should go in for patterns of the FM engine. And to define single word utterances, use the less than greater than sign. Basically, they are anchors. They are known as anchors, and they anchor the word following like lesser than sign followed by a word. FM engine will look for that word at the starting of the utterance of the user. So many a time you come across situation that if the user starts his utterance with a specific word, then the task should be qualified. It does not matter what he has said after it, okay? But since his utterance has started with a given word, a particular task has to be qualified, okay? That is where you can use the less than sign followed by the word. If you use a word followed by the greater than sign, FM engine will look for that word at the end of the utterance of the user. So no matter what he has said before that, since his utterance has ended with that specific word, FM engine will qualify the task. And when a word is enclosed between both of those anchors, the word is all by itself in the utterance of the user. Okay, so that is why those operators are known as anchors. Okay, starting of the sentence, ending of the sentence. Okay, is it clear to you all this particular operator? Okay. The next use case where you should be using patterns is in idiomatic sentences. Okay, this is the second use case where do not consider ML utterances, rather go in for patterns. What are idiomatic sentences? Idiomatic sentences are sentences which clearly do not tell you what is the task the user wants to perform, but inherently it means a particular task. Something like if the user says, am I a rich person? Now here, in this entire utterance, there's nothing similar to check balance. Okay, no synonymous words, no words which mean similar to either the word check or to the word balance. Nothing is there. Okay, but when the user is asking, am I a rich person? For a banking bot, the best task that can get qualified is the check balance task. Okay, he can see his account and with his balance and understand how rich he is. Okay, so this kind of statements are known as idiomatic sentences. Okay, something like today, let's say you have a weather bot. You have a task over there, fetch the weather condition, current weather condition. And the user asks the bot, do I need to carry an umbrella? I'm stepping out. No way he has expressed his intent to check the current weather condition. But since he's asking a question like this, that does he need to carry an umbrella? The best thing the bot can do is to return the current weather condition. So then the user can understand whether he needs an umbrella or not. Or maybe let's say you have a travel bot. Okay, you have a flight booking task over there, and the user says, my mother has been hospitalized, something like that. He didn't say that he wants to book a flight or anything, but when he has said something like this, my mother is hospitalized, it means indirectly that maybe he wants to fly. Okay, so the task that should be qualified is the book flight or something like that. Okay, so these kind of sentences are known as idiomatic sentences, which clearly do not tell you what is the task, but inherently they mean a particular task. Okay, idiomatic sentences should always be handled through patterns. Don't go in for ML utterances, because once again, due to the similarity of words, matching with utterances which are trained for other intents, ML engine might incorrectly qualify some other task. Okay, handle idiomatic sentences always through patterns. Okay, so here what I can do is this thing like, am I a rich person? Okay, so if the word rich is found in the utterance of the user, the task to be qualified is the check balance task. Okay, I have a few more examples of idiomatic sentences. I'm just going to copy that and put it over here. So I can say if the user asks, what is my financial worth or what is my monetary status, things like that should lead to the qualification of the check balance task. Similarly, if the user says my friend is in need of money, or maybe my family needs some urgent cash, for all of these things, the task to be qualified is the make payment task. So consider all idiomatic utterances, and if you come across these kind of utterances, in that case, always go in for patterns, not for ML utterances. So these are two use cases where you should specifically consider patterns. Or if you feel your intent identification is very rule-based, like the order of the words is very important, okay, or the position of the words, like it should be at the starting of the user's utterance, or the word should be at the ending of the user utterances. So if you have rules like this, then only go in for patterns. Otherwise, always go in for ML training. Okay. I don't specify the word need. It is automatically handled. So any 3 words, I don't need to do that. Okay. So right now, if I talk to the bot and if I ask that, am I a rich person? You will see the task getting qualified is the check balance task. Okay. And how did this task get qualified? This task got qualified by the FM engine. Okay, so you can see the check balance task qualified as a definitive match, and using the pattern that I have defined. The pattern is the word rich. Okay, remember, when you are defining patterns, unless and until you make words optional over there, patterns has to match as a whole. Okay, so if there are optional words, then that word may or may not be present. Otherwise, whatever you define in a pattern, all of those words has to be found in the utterance of the user. Okay, nothing is optional without the optional operator. Is it clear till here? Any questions on patterns? Okay. Now coming to the next part, that is synonyms. Okay, so like I was saying, you know, like for the word balance, okay, there was this that if the user types in BALLANCA, okay, how does the bot rectify? Now look, for common English words, for certain, for certain words which are very common, you will see bot automatically corrects that. Okay, if there is a built-in bot dictionary, and the spell correction always takes place when the NLP is processing the user utterance. So many common words are automatically taken care of. So when you think of a misspelling, first type it in and see whether the NLP is automatically correcting it or not. But if it is not correcting it, in that case, you come to the synonym section, bot synonym section, click on new synonym, okay, type in your original word, and in the synonym section, type in all the possible misspellings, okay. You can just say bal, okay, so something like that, okay. Type in, think of all the possibilities. If there are acronyms, if there are abbreviations to be considered, all of those should be provided in the synonym list. And once the synonym list has been defined, okay, let us see whether the spelling mistake is handled by the bot or not. So once again, it will be the FM engine using the word match algorithm, but can it do it now or not? Okay, so you can see it has qualified the task correctly. And if you come here, okay, So you can see those spell correction which had taken place did not correct the word, because the balance, there is a word maybe like that in the dictionary. That is why this was not taken as a spelling mistake. But still the task got qualified as a definitive match by the FM engine. How did the word BALLANCE match with the label word balance? It matched through the synonym. Okay, so the input word balance matched with the label word balance, and you can see that you can understand over here how did BALLENC match with the label word BALANCE, because it has been mentioned as a synonym of the word balance. Okay, is it clear to you all? And this is a broad synonym, which means if other tasks are also using the same word balance, FM engine will always consider this list of synonyms. So you do not have to mention it separately for every task. It is added at the bot level, and it will be used for qualification of all tasks which use the word balance in the label words. Is it clear to you all? Any questions on that? Many a time in the ML utterances, we might define token words or important words in the ML utterances where there is a possibility of spelling mistake. We might handle those possible spelling mistakes by the synonyms. But remember, ML engine does not use the bot synonyms. It is by default used by the FM engine. So that is why if you want the ML engine to use these synonyms to rectify those words in the user's utterance, so that the confidence score goes up, come to the machine learning threshold section. Okay, come to configure over here, and you can see there is a section called bot synonyms. It is disabled. That is why the synonym section is not used by the ML engine, but you can enable it. The moment you enable it, if there are synonyms to handle spelling mistakes of the token words, which you important words, keywords that you have added as training utterances, ML engine will consider the synonyms, and the confidence of ML engine will obviously go up. Is it clear to you? And this is where we give the threshold for the minimum and the definitive match. So the similarity has to be minimum 30% by ML engine to even consider the task. Similarity less than 30%, the task will be eliminated. And more than 95% similarity is taken as a definitive match. You can bring it down till 80%. If you feel 95% is too restrictive, you can bring down this definitive match score till 80%. Okay, but whenever you're making changes in these, make sure you test your bot thoroughly. If you're not sure about the changes, if you don't like the output of that, click on the reset button to come back to the default settings once again. Okay, is it clear to you all? Any questions? Okay. Now coming, so once again, quickly recapping what we have discussed till now, two ways of training NLP for dialogue task identification, ML engine, FM engine. ML is trained with training utterances, FM is trained with synonyms and patterns. When you're starting with the training, your first approach should always be training the ML engine. That should get the highest precedence in training. Try to list out as many possible utterances that can come from the user. Pick up the keywords from there. Don't add utterances blindly, because you might be adding words which actually mean nothing. And those can be common words which can be used across multiple tasks. Okay, so leave out those pleasantries, those not important words. Pick up the important words from the utterance, add it as a training utterance. If there are possible entity values to be considered, make sure that you tag it with the respective entity, which will improve the scoring of the ML engine, and add as many utterances as possible, because ML learns by experience. for specific situations like single word utterances or idiomatic sentences or rule-based intent identification, like the positions of the word in the utterance of the user, the order of the words in the utterance of the user. If these are important factors to be considered while intent identification takes place, in those cases only go in for patterns. Okay, because if you define too many patterns, go down the line, you will find it is very difficult to maintain the patterns. So a pattern should be the last resort and should be used only to handle these specific use cases. Okay, misspellings, abbreviation, acronyms can be handled through synonyms. By default, synonyms are only used by the FM engine with the label word match algorithm. But if you want to define synonyms, want to handle misspellings and all for the words which you have added in the training utterances for ML engine, then you have to enable the use of bot synonyms for the ML engine. Okay, so this is how you should be doing it. Where do we see or find? See, there is a list of default synonyms, okay, a system defined synonyms, which you can see every time when you create a bot, you will see in the synonym section, you get a lot of predefined synonyms. So these are certain things which are defined within our platform. In addition to that, anything is there, you have to define it. Okay, and this, it has to come with the training. Okay, so this differs from domain to domain. So you have to, as an NLP trainer, you have to list out all those utterances, see the variations, think of the misspellings. When you see users talking, if you see misspellings over there, you want to handle all of those. That is where use synonyms. So there are some, system defined ones that you can see over here. Okay, and additionally, you can define your own synonyms also. Is it clear? Okay, quickly coming to concepts. Okay, concepts are collection of words which can be used in patterns. Synonyms cannot be used in patterns. But let's say today I want to define a concept. Okay, so I click on concept. A concept name starts off with the tilde sign. It looks very similar to synonyms actually. Okay, so let me just create a concept called currency. And here, let me put a few currency names like dollar or pound or euro, and so on. Okay, I can keep on adding as many words as I want, just like synonyms, only differences that starts with the tilde sign. Now, why did I define this concept? Concepts can be used in patterns. So at times, maybe a list of words that you are using in patterns can be used across multiple patterns. Okay, so do you want to define that list of words again and again across multiple patterns? You can do that, but a more efficient way of doing that is through concept. So the user can say check, fetch, show, see, and so on, followed by balance, cash, or money. Or the user can use one of those currency names, like show the dollars in my account, or how much, show the available euros in my account. So here, what he's doing is, instead of saying balance, money, or cash, he is using one of those currency names which are defined within the concept. Okay, so what I do is I put tilde followed by currency. Okay, so I'm using the concept that I have defined within my pattern. Remember, only concepts can be used. Synonyms which you have defined cannot be used. Okay, similarly, I can use the same concept in some other pattern. Okay, so what I can do is I can come to the make payment task, and here the user can say pay dollars or pay euro, something like that. Okay, so the same list of words can be used here also. I don't define that list all over again. Quickly, I just use the concept. So this is a very efficient way of handling a list of words which can be used in multiple patterns. And one more advantage is that tomorrow, if there is any change in that list of words, you want to add a new currency over there, currency name over there, then you do not need to make changes in the individual patterns where that list of words is defined. Just come to concept. Okay, so you can search for that concept from here, or you can see the concept here. Click on the edit button, and add the new concept over here, the new word over here. The moment you add that, this change will impact all the patterns where this concept has been utilized. Okay, is it clear to you all? And concepts are used in small talk also. So you can see yesterday we were seeing that emotion high. Okay, so if you come down over here, yeah, emotion hello. So you can see hi, good morning, good evening, good to meet you, good to see you again. Okay, greetings. All of these words has been put together within this concept, and this concept has been used in the small talk, which means any one of these words, any one of these phrases, if they are found in the utterance of the user, the response is put in the small talk. Okay, so you can use concepts in patterns for intent identification, or you can use concepts within the small talk also. Okay, is it clear to you all what is concepts and where to use concepts? And the difference between concepts and synonyms is also very important, because both of them look similar, but synonyms cannot be used in patterns. Only concepts can be used in patterns. Any questions on this? Okay. Now coming to the training of the knowledge graph engine. Till now we were speaking about the dialogue task identification. Yesterday we have seen that NLP engine or KG engine, the knowledge graph engine, qualifies a task, an FAQ if the utterance of the user matches with the FAQ exactly, or if there is a similarity, once again, there is in the thresholds and configuration, we can specify that similarity score. The working of the KG engine is similar to ML engine. It looks for similarity between the utterance of the user and the FAQs that are defined. And depending on the similarity score, it qualifies a particular FAQ. It keeps on evaluating FAQs, okay, till it reaches the end. And depending on the total number of FAQs that get qualified against the utterance of the user, the ranking and the resolver engine declares the winning intent. Okay. Now, at times what happens is we want to organize the FAQs better. Okay, so you can see over here, there are a few questions with home loan. Okay, there are a few questions with personal loan. Okay, there are a few questions with car loan. Okay, I have a few questions over here with car loan. Okay, there are questions for credit card or debit card. Okay, there are questions for savings account or current account. Okay, now I want to organize these questions separately into different sections. Typically how it is organized in any FAQ pages. Okay, if you go to any website, you will see they are segregated on the basis of the topics. Okay, and the questions, similar questions are put within the same topic. Now, how do you organize questions in that way? Okay, the first thing is, once you add the FAQs, try to identify the key terms. Okay, so here the key terms are like, in my question set, I have key terms like, car loan. Now this takes time for me. I keep on using this set of questions. I know what are the key terms. So home loan, then you have personal loan. There are questions related to, questions related to credit cards. There are questions related to debit card. There are questions related to savings account. And there are questions related to current account, which can also be treated as a checking account. Okay. Now, if there is a single question related to, these are important parts of the question, important, these are the subjects of the question. So these words are important for qualifying the question. Okay. So if you look into a question, you will understand that for this question, what are the important words? The important words are generate, the important word is pin, the important word is debit and card. Okay, these are the 4 important words which KG should learn to qualify this question. How can I and for my, these are not important words for these questions. What are the important words? Generate, pin, and debit card. Okay, now if you look into this particular FAQ set, there are other questions also where the word debit and card are repeated. But maybe with some other word, like working over here is important along with debit card. Okay. So if you see, there are important terms which are repeated across multiple questions, then we put those important words at the ontology level, which is a hierarchical structure of these key terms identified across multiple questions. So you should understand the difference between the two. These are important words, but if the important word is with respect to a single question, I can create a tag. How do I create a tag? I come here. Okay, and for this question, I say generate is a tag. When I say generate is a tag, KG will learn if this word is found in the utterance of the user. Since this word has been tagged to qualify this question, KG will have more confidence when it is scoring this particular question. Okay. Similarly, pin is an important word to qualify this question. Okay. So when those words are at a single question level, important words which are at a single question level, you can create the tags of those questions just below the question. Okay, over here, by clicking here, you will see the platform comes back with suggestions of important words. You can also type in the word. Okay, but the word debit and card, I'm not creating them at question level. Why I'm not doing it? Because there are multiple questions which contain that same word debit card. So for each of those questions, now today, if you have 100 questions for debit card, do you think you should go and open each of those 100 questions to create those tags to improve the confidence of KG? No, that should not be the approach. Then how can I do it? We come to the ontology on the left-hand side, and those important words which are common across multiple questions, we create a hierarchical structure of those terms. Why an hierarchy? Because the common words like car loan, home loan, personal loan. Loan is a common word. Okay, so I put loan at a higher level in the hierarchy with a child term under loan as car, home, or personal. How do I do this? We click on the plus sign to create a child node under the root node, which you can see over here. And here I put the first level node as loan. Another first level node I create as card, and another first level node I create as account. Okay. Now, once I do that, under loan, I have different types of loan, questions related to different types of loan. So it can be a car loan question, it can be a home loan question, and it can be a personal loan question. In the same way, there can be questions related to credit card. So I create credit as a child term under the parent term of card. Similarly, I create debit as a child term under the parent term of card. And in the same way for account, I create two child terms, one called savings, okay, and one called current. Now, how do I associate questions? This is not all. Okay, these should be associated with the questions so that KG knows that if these words are found, these questions should be qualified. Okay, not any other question. That is the purpose of this entire effort. So we go back to the root node. We'll just take a break in 5 minutes. We'll go back to the root node, and you can either manually go through or you can filter. I'd say car loan, press and enter. It picks up all the questions which have these common words. Click here, drag and drop it over here. Okay. In the same way, the root node will always show you all the questions. So I go and filter for home loan. Okay. Once again, I pick up all my questions from here, drag and drop it to the node with which I want to associate it. Let me just quickly do this. It's a repetitive process. It takes a little time. So, and this training, you know, whether you want to define this important word at the question level or at the ontology level, understanding that, identifying that also takes a little time. You have to understand, you have to see whether those important terms are repeated across multiple questions or those important words are present in a single question. If it is at a single question level, go in for building the tag at the question level. Don't add it at the ontology level. But if you see multiple questions have those important words and you want KG to learn the importance of those words to qualify the question, then build the ontology and build it in a hierarchy. Okay, don't create single terms with two words and all. That's not a good way of training it. Repeated terms should be at a higher level, and exclusive terms should be at a child level. Okay, so going back for savings account and
Hello.
checking. Yeah, please go ahead.
Hello.
Yeah, please go ahead.
Hello.
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 You are not, am I not audible to you?
Hello. हाँ भाई.
Okay. There's another, please be on mute. If you are talking on some other line, please be on mute. It will be easier for us. And finally, we come to the last one, that is current account. Once we have created this, let us train. Remember, with every change that you do on the knowledge graph, you should train the KG engine. And once you do that, let us see how this ontology helps the knowledge graph engine to pick up the question. Okay, so now if I say there is a question like this, what is a pre-approved car loan? Okay, there is a question like this, so you will see the response of that coming up over here. It was coming up earlier also, so you can say, why do I need to go in for this? Yes, of course, but this gives a better organization to your KG actually. And you will see once the ontology has been built or tags has been defined at the question level, that is path level terms has been defined, you will see KG actively using those terms or these keywords to qualify the question. Okay, so you come to the FAQ section. You can see in extracted entities section, what are the words which were considered from the utterance of the user to qualify those terms, okay, which you have defined. Okay, so right now I have defined at the ontology level, car loan, home loan, personal loan. So you can see in the utterance of the user, the words car and loan were picked up, and these terms were used to qualify this particular path from the ontology. Okay, so you can see the other paths did not get qualified. Only this path got qualified, and from the qualified path, there is a question that matched with the utterance of the user. So KG returned the response of the question. So this time KG, if there are thousands of questions, let's say today your knowledge graph has 10,000 questions. So with an utterance coming from the user, KG is not evaluating all those 10,000 questions to find similar matching questions with the user's utterance. Rather, what KG is doing is first from the ontology, it is trying to qualify a path using the keywords that you have defined within the ontology. And once a path in the ontology is getting qualified, then only the questions which are associated with that path, KG looks for a similar question within that associated path. Okay, so this reduces the search range of KG. So it ensures that if there are huge lot of questions, then the response time decreases subsequently. That is one of the issues. And it also organizes better the questions. So today, if you want to look into any questions, all the questions related to car loan, you just have to come here, click on this term, and you get to see the questions. You don't have to go through the thousands of questions. So today, if I tell you to pick up our car loan, you have to go through all of these questions and check out what are the questions related to car loan. So quickly, you can come here, just click here. It will show you all the questions. And after the break, we will see what further training we can do for these question identification on the terms, on the basis of the terms that we have defined within the ontology. Is it clear to you all the purpose of creating the ontology and how should we do it? Any questions on that? Okay, let's take a break of 10 minutes and then we will continue with the rest of the session. I hope all of you are back from the break, and let us continue with the rest of the discussion, where we will start off with what further training can we do for FAQ identification on the basis of the tags we have created at the ontology level. Okay, now let us say I just make a little change in my utterance. Okay, my last FAQ was what is a pre-approved car loan. Okay, so my path got qualified, and KG found a question which matches exactly with the user's utterance. So the question was qualified as a definitive match, and the ranking and the resolver engine declared that as a winning intent. Okay, now I'm just making a small change in this entire question. Okay, where I say what is a pre-approved auto loan. Okay, now here I have not trained KG till now to understand that auto is a synonym of the word car. Okay, so in that case, the confidence of KG has come down, and two questions are getting qualified, and there are two questions which are similar, one belonging to the home loan, one belonging to the car loan. Now, why are these two questions getting qualified? Okay, so if you come to the NL analysis section, you will find that the tag qualification. Okay, so there's only one word which was used for tag qualification from the utterance of the user. The word is loan. Okay, and that loan word was found in the ontology. So through that single tag, there were two parts that got qualified. Okay, so home loan and car loan, both of them share this common tag, that is loan. Okay, so both of these parts are qualified. In fact, the personal loan path is also qualified, and from the qualified path there are two questions which matches with the utterance of the user. One is what is a pre-approved home loan, the other is what is a pre-approved car loan. Okay, so since both of them are similar to the utterance of the user, though it is not a definitive match, it is a possible match. So now what the ranking and the resolver engine does is it declares both of them as a winning intent. So you can see the ranking and the resolver engine declaring what is the pre-approved car loan and what is the pre-approved home loan as a possibility against the utterance that is coming from the user. So now to resolve the ambiguity, both the questions are presented to the user. The user can select the one he wants to proceed with. Okay. Now, two things to understand over here. Why did the presence of loan why was loan, the presence of word loan good enough to qualify both of these parts, and how we can train KG better to understand that auto is actually a synonym of the word car, so it should not consider the home loan question at all. Okay, so if I click now on car loan, it will show you the response of this. So yesterday also I got a question like, if there are multiple FAQs which are qualified, how does the user get the response? So if finally the ranking and the resolver engine is not confident on any of it, then it will present the choice to the user in this way. Okay, and let the user select the one he wants to proceed with. Okay, but we as developers, we can resolve this issue. We can avoid this ambiguity. How can we do it? But first, let us understand why the presence of loan was good enough to qualify both of these parts. Okay, for that, we come back to the thresholds and configuration of the KG engine now. And here you can see path coverage is at 50%. It means, like, let's say for question one, for a given question, okay, any question, okay. So for question one, you have defined 4 words as tags. Okay, it can be at the ontology level, it can be at the question level, or path level, it is known as. Okay, so you have 4 words. Okay, so you have tag 1, you have tag 2. If it is at the ontology level, there can be a hierarchy, but internally it is all flattened. Okay, so tag 2, you have tag tag 3, and let's say tag 4. When I say tag, it means important words to qualify this question. Okay, so in this way, maybe a few tags are at the ontology level, a few tags are at the question level itself. When you see path qualification is at 50%, it means this question will be qualified if KG finds at least 2 of these tags in the utterance of the user. So from the words that you have marked as important to qualify those questions, okay, at least 2 of those words has to be present in the utterance of the user. If it is like, let's say you create 3 words as important words. Now these words can be at the ontology level if it is shared with between multiple questions, and it can be at the individual question level also. Okay, but if there are 3 words, 50% means, of course, more than 1 word. Okay, so if a single word is found, then it doesn't qualify. More than 1 word, so it's nearly 2 words has to be there in the utterance of the user out of the 3 words which has been tagged for that question to qualify. Right now, how many tags are there for qualification of a question? 2 tags only: car and loan, home and loan. Okay, so for the questions belonging to car loan, these are the 2 tags. For the questions belonging to home loan, these are the 2 tags. Okay, out of that, 50% means any one term. Okay, so the term loan is found in the utterance of the user. So that is 50% path qualification or term qualification, as a result of which KG qualifies these questions against the utterance of the user. Okay, if you want it to be more strict, that all the words which has been tagged should be present in the utterance of the user, you can increase it to 100%. If you want it to be a little more strict, you can change it to 75%. That is at least 3 words out of 4 words. Why I'm using 4 words as a boundary? That is, we say do not go beyond 4 words when you are tagging. Okay, when you are qualifying important words, do not make it more restrictive for KG. Give some flexibility to KG also, because when you mark words as important, KG understands those words has to be present in the utterance of the user. So pick up really important words from there, and do not go beyond 4 words. Okay, 4 tags is good enough for KG to qualify the question. Okay, so if you want at least 3 words should match with the utterance of the user, then change it to 75% also. Okay, so it depends on you how you want the path coverage, but the default is 50%. That means at least 50% of the terms which are present in the should be present in the utterance of the user for a particular question to qualify. Is this clear to you all, this path coverage and how it is working? Any questions on that? Okay. Now coming back to KG, I want to resolve this ambiguity, because I can understand looking at the response, the home loan question should not qualify at all. Okay, so how can I handle that? The easiest way is, since I have defined car as one of the terms over here, I come to the settings of it and I can provide synonyms of this word. Okay, so I say auto is a synonym of this word. I say vehicle is a synonym of this word. I can say four-wheeler is a synonym of this word, and you can continue with the list. Synonyms is a very good way of handling, variations. So we might be challenged when we think of synonyms, but you can look into the online dictionaries and all, and pick up relevant synonym words and train your bot to understand those synonyms. Okay, save it. Similarly, let's say I provide some synonyms for home, it's a good way to do it, so you can just keep on doing it. And you see that. Now, once you do that, let's train. You should perform all as far as training possible and then check, but I'm going to show you all before the training and after the training. So I'm going to train KG with every change that I do and then show you the result of that change. Okay, so now I repeat this question once again. What is a pre-approved auto loan? Last time there was an ambiguity. Last time there was an ambiguity, okay, but let us see this time whether there is any ambiguity or not. So you can see the response has come back. You can see the primary question that got identified. And if you come to the NL analysis section, once again, you will see the extracted entities or the terms which were used for, the stack qualification is auto and loan. Why was auto used? Auto was used because auto is a synonym of the word car. Okay, so using these terms were qualified, and using these terms, there was a question that matched with the utterance of the user. So KG qualified that question as a definitive match, and ranking and the resolver engine declared that as a winning intent. Okay, is it clear to you all? Any questions still here? Once again, I'm just changing this question, and I'm just playing around with this question only. The same, you will see the same behavior across all the questions which are defined within your KG. Okay, so I say, what is a pre-approved, let's say, loan? I don't say auto loan, I don't say car loan, I don't say home loan or anything like that. I just say what is a pre-approved loan. Once again, you can see the suggestion. Why? This time, I guess you all can understand, because one of the terms, there are two terms, two words marked important for qualification of these questions, out of which one of the terms is found in the utterance of the user. Path coverage is at 50%, so that condition is satisfied. So KG presents a choice to the user of the questions which are similar to the utterance of the user. Now the user can select the question for which he wants a response. Now this is a proactive nature of KG, and it works well with most of the implementations. But here, I'll be sharing the recording of this session. So if you have any questions hearing the recording, feel free to mail me your questions, okay? So now what happens is, if you want to be very restrictive, that the user needs to be clearly telling whether it is a car loan question or a home loan question. How can you imply, you can implement a restriction like that? You can come to the term, and from term usage, you can make it a mandatory term. The moment you say it is a mandatory term, this term was important to qualify this question, but it also worked with the, the path matching this thing. Okay, how many terms are matching? Okay, if it is 50% path qualification, then also it was working. But the moment you say that it is a mandatory term, it means either this term or synonyms of this term has to be present in the utterance of the user for the questions associated with this term to qualify. If the word car or synonyms of the word car is not present in the utterance of the user, even though if we have the word loan, that 50% path qualification is not good enough to qualify the questions associated with these terms, because these terms are mandatory terms, which means these terms has to be present in the utterance of the user. Let us see what is the change in the behavior. So for that, we just train it quickly, and let us go back and talk to the bot. So you can see intent identification has failed. Why did it fail? This time also the term loan is there. I have not changed that path qualification from 50% to something else. So that should have worked. But my child terms are mandatory terms. So those words has to be present in the utterance of the user for the qualification of that particular path. Okay, so now if I say what is a pre-approved home loan, you can see the response coming up. This is a dummy response that I have added, so it's coming up like this. Just a simple response. So you can see in the path qualification, these two terms were picked up, and in the demystification, which will show you the words which were used to match those tags that you have defined, you can see this asterisk, which means that this term is a mandatory term. So this term should match exactly or it should match by a synonym. If this term does not match, the question for which this with which this term has been qualified has been associated, the question will not qualify. Okay, is it clear to you all the purpose of mandatory tags? Okay. We also have something called organizer terms, just like mandatory terms. And the purpose of organizer terms is, at times you have some questions in your bot, okay, which cannot be, for which you cannot define, common terms at the ontology level. Okay, ontology level is common terms across multiple questions. But you have single questions, and maybe there are some words, within those questions which are important to qualify those questions. But at the ontology level, when you are defining, terms to associate multiple questions with which contain those common words, these questions do not have anything like that. They are standalone questions. But you want to organize all the questions within some term in the ontology, so that if you click, one of the purposes of this is whenever you click on any of the terms, you can see all the questions which are associated with that term. So easily you can see those questions. So you want to do something like that for those standalone questions also. So what I do is I create a term over here. Let's say, I create it as let's say, general questions. Okay, so I just put the term name as general. I come back to the root node, which shows all the questions in this particular bot with the name of the term to which it is associated. If you just want to see the questions which are not yet associated with any of the terms defined in the ontology level, click here, the second tab, which will show you the questions which are not yet associated. I have only one question like that. So I click here, sorry. I select this question, I drag and drop it over here. Now, when I drag and drop this question to this, one second. Okay, when I associated this and I, train it, do you think the bot will answer this question? The bot will not answer this question, because if 50% path qualification is required, there are no additional tags in this question. And it is associated at the ontology level with a tag called general. That means at least this word has to be there in the user's utterance to qualify this particular question. Now, if this word is not found in the user's utterance, this question will not qualify, because that tag qualification becomes important once you tag those important words, okay, either at ontology level or at question level. So now what do we do here? Okay, how do we tell KG that this word is not important to qualify this question? Because this is just created to organize a few questions together. Okay, it should not play any role in path qualification of this particular question. In that case, I come to the settings of this term and I change the term type to an organizer term. Okay, so many a time you will come across organizer terms where you just want to club a few questions and store it together for your visual preference, to easily see those questions, but you do not want this term to play any role in path qualification. Okay, if you do not mark it as an organizer term, this particular word will play an important role in the qualification of this particular question. Is it clear to you all the purpose of organizer terms? Okay. Now coming to path level, we have seen how we can define path level, these things. Another usage of that can be, we have a question like what is a one second. We have, how do I repay a home loan? Okay, so if I have a similar question. I'm just putting a dummy response over here, okay? Now, both of these questions, the common term is home loan. Okay, so that is why I've associated it at the ontology level with home loan. Okay, but within these questions, there are important words which I can train KG with, which will help KG to qualify these questions better. What are those important words? For this question, apply is an important word. For this question, repay is an important word. Home loan is important, but as it is common across multiple questions, I have put it at the ontology level. Think of the ontology only when you have common terms like this. If you do not have common terms, like I have apply and repay, but these are for specific questions. So I'm not going to build a term in the ontology. When it is for a particular question only, then what do? We mark that as a tag at the question level. This is known as a path level tag. Okay, this is an ontology level tag. Okay, so I come here and I say apply is a tag at the question level. So KG knows now, along with home loan, which are important words to qualify this question, the word apply is also important. Okay, so out of these three terms, if 50% qualification is more than one term. Okay, so this question will come more than one term. So in this case, it will be two terms. Then only this question will qualify. And once you have defined a term like this, you can click on this. You will get similar settings like the ones you got at the ontology level, where you can make the term a mandatory term. If you want to define synonyms for apply, like, take, or how do I get a home loan? How do I avail a home loan? So these are all synonyms of the word apply. You can search for more synonymous words and you can put it here. And let us see this. In the same way, I can create repay as a tag because this is an important word for this question. We are training KG so that it does not get confused between these two questions. So we are training KG to understand those important words within the question. Okay, so I say repay is an important question tag, and I can make that also mandatory. Mandatory tags are a restriction, so think about it whether you really want to make it mandatory or not. Or you can just provide synonyms like repay can be prepay, or it can be close. Okay, it can be payback. Okay, it can be refund. Again, think of all the possibilities, or return. So these are all synonyms of repay. Click on that. And once you do that, save it. And once it is saved, let's train it. So you can see the primary question is how do I repay a home loan, and how did that get qualified? What was the question, tags or words which were considered? You can see payback, home, and loan. Three tags were considered over here. And using those three tags, this is the question that got qualified at KG. FA, this ranking and the resolver engine declared it as a winning intent because this is a definitive match. KG is confident this is the question the user has asked. So now the ranking and the resolver engine declares that as a winning intent, and the response is displayed in the conversation window. Okay. So these are the ways in which you can improve the training of the KG engine. Before we end this one, additional training. Yesterday, we have seen that we can add alternate questions. Even for the alternate questions, you can define tags that are important words within those alternate questions. Okay. You can also handle multiple alternate questions using patterns. Okay, just like we were using patterns for the FM engine, in the same way, you can use patterns for handling multiple alternate questions together within KG also. So I have a pattern ready so that I don't have to type it. So a pattern for KG should, start with the double pipe symbol. Okay, so immediately you can see pattern written on the on right, telling KG engine what comes after this is a pattern. So the word procedure, I have synonyms of that word over here. For repay, I have a few synonyms. Now within a pattern, if two words come one after the other with a space in between, no other word allowed, then you can separate those words with an underscore. You can use this in the FF patterns also. This means pay and back, the two words one after the other separated by a space only, no other words in between. So many a time you come across groups of words like this. When used as a group, they mean a particular thing. Okay, so that is where to define those groups of words one after the other, separate the words with an underscore. Similarly for settle up, there will be a space, but no other word or character allowed between these two words. Okay, so this is how you can define a pattern. You can have a pattern to handle multiple alternate questions. You can also add a few other alternate questions, but the first question should be the question in a simplest form. It cannot be a pattern, and this is known as the primary question. Okay, so once you do that, you can save it. So you can see using the sing pattern, an FAQ got qualified and the response is returned. And you can see the tags has been used to qualify the path. Okay, so you can see these two tags. These are at the ontology level. Unless and until 50% of these tags match, the question will never be qualified, even if you have defined a pattern. So at least the tags has to match by 50%. And then you can see after the path qualification took place, then the question got qualified using the pattern that has been defined. And this is the primary question that got qualified as a definitive match. So finally, the ranking and the resolver engine declared it as a winning intent, and the response was displayed in the conversation window. Okay, so these are the different ways in which you can train KG to qualify questions better. Okay, any questions on anything? What about user phrases, words, question that the bot doesn't have configured yet? What does this mean? Can you give me an example of that? Because if it is coming from the synonym list, you have to go in for the bot synonym section, and the default ones are given there, inherited from the our platform for every bot that you build. Any additional domain specific word, you have to define it. Okay, same goes for concepts. The default concepts which are used in the small talk greeting section, you will get to see it for every bot. Additional concepts has to be defined for you. Okay, user phrases, words, questions that the bot doesn't have configured yet. What do you mean by the bot doesn't have configured yet? Do you mean the bot dictionary? We have a collection of common words, but that is not visible to the developers. It contains all the common words of the English language. But for domain specific words, when you're building a bot, if you see the word is very specific to the domain that you are using, then you have to go in for the same. Okay, and you can understand while you are testing the NLP engine whether NLP has the understanding of that word or not. If you see NLP does not have the understanding of that particular word, you have to train NLP to understand that. Okay, so that is how it works. Okay, if it is for synonyms and concepts which are by default available, if you go to those sections, the default ones are always displayed for any bot built in any language. So for different languages, we have different sets of synonyms and concepts defined. So go to those sections and see what is inherited, and then add your own ones over there. Okay. You can also use the synonyms and concepts which you have defined, in the natural language section for qualification of questions in KG, and concepts can also be used in the patterns that you are defining over here. But by default, KG does not use those synonyms and concepts. For KG, you have to mention, create the synonym list separately, okay, by providing the synonyms over here. But if you want to use the synonyms which has been defined at the bot level, then come to this 3 ellipses over here, come to manage synonyms and enable bot synonyms. So just like for ML engine, you have to enable the use of bot synonyms. In the same way, you have to do it over here. Then only if you have defined some synonyms of some words to handle misspellings and all, you will see if those words are found in the FAQs, it will be automatically corrected, and the bot can understand that. Just like we saw for balance, okay, BALLANC. Initially, it was not handling it, but once I went in for providing that as a synonym, NLP was able to qualify the task correctly. Okay, but KG by default does not use that synonym list. So make sure you enable the synonym list from here. Clear? Now going ahead, till now what we are talking about is how to train it. Okay, now let us see with the testing. I'm going to show you how we can see the actual working of the ranking and the resolver engine. Now for testing, as I was testing through, talk to the bot, but talk to the bot is usually for testing the entire flow. Okay, that is the dialogue flow, the entire conversation flow from the starting to the end, starting with intent identification, then with entity extraction, and how the response is finally displayed with API calls and everything. Okay, so that is the purpose of flow testing, testing the flow end to end. But just for intent identification, talking to the bot may not be a good process. So you just want to see whether the intent is getting qualified or not. So we have another tool over here, which will allow you to just see what intent is getting qualified. That tool is available under the testing module over here, and that is called the utterance testing. Now here in utterance testing, you can type in different utterances and see how intent qualification is working. Okay, so something like this, if I say, okay, so this is an utterance. I say, can you show the money in my account? Okay. Now let us see which task is getting qualified. You can see intent identified as the check balance task, and you will get a summarized view of the NLP processing coming up on the right. It takes a little time to, provide the summarized view. Okay, so let's wait for it, and then let's understand how exactly it is working. So it will show you the result of each of those intent identification engine, and finally how the ranking and the resolver engine declared the winning intent. You can see machine learning engine had qualified the task check balance, okay, as a possible match. Why? Because the word money is found in a few utterances. In the training utterances for check balance, okay, we had 2 utterances where we have used money. Using that, machine learning engine has qualified check balance as a possible match. You can see the similarity score by clicking here, and you can see 69% similarity between the training utterances and the utterance coming from the user. Fundamental meaning engine has qualified the open account task as a possible match. Why? You can easily understand from here, it matches the label word account with the word in the task name. Okay, so the word account is found in the utterance of the user, though the word open is not there. So partial label word match has led the fundamental meaning engine to qualify open account as a possible match. But check balance task got qualified as a definitive match by the fundamental meaning engine. How? If you click here, it will show you the pattern that it has used to qualify the task as a definitive match. Okay. And so finally, you can see from the arrow, the ranking and the resolver engine has only considered the task which qualified as a definitive match and declared that task as the winning intent. Okay, so this task got declared as the winning intent. The winner is this particular task. Okay, you can see the reasons for elimination because another task was found as a definitive match. So this task got eliminated. Okay, so in this way, from the utterance testing section, you can type in different utterances. Okay, and see how tasks are getting, qualified. Let's say I say transfer money. Let us see what is happening. This is a very interesting tool. You can use this tool frequently. Type in after you train, type in different utterances and see which intents are getting qualified. Okay. So it takes a little time to generate the output, but you can see the make payment task getting qualified. Though check balance task had been qualified as a possible match. Once again, the presence of the word money led the machine learning engine to qualify check balance task as a possible match. But since the fundamental meaning engine had a pattern to handle this particular utterance coming from the user, using this pattern, the task got qualified as a definitive match. So finally, the ranking and the resolver engine declared it as a winning intent. Okay, so you can see how this multi training approach is helping NLP engine overall to find out which exact task needs to be identified. Okay, let us try with something else. I say, how can I open a current account? There's an FAQ that matches with this. Okay, so let us see what is happening. So you can see this FAQ, though open account task was a possible match over here, but the KG question got qualified as a definitive match due to 100% path qualification. So these terms are present in the utterance of the user. And you can see over here, this FAQ has qualified. Okay, so through the path qualification, it has qualified. Let us make a little changes in this question. Okay, we will try with different changes. If I say, how can I open a savings account? Okay, let us see whether this FAQ is getting qualified, because since it is an FAQ, maybe it does not match exactly, but still this FAQ can answer the query of the user. Okay, so let us see finally whether this FAQ is getting qualified or not, though 50% path qualification will take place from the FAQ's end, okay, KG end. So let us see which is the winning intent finally, because once again, open account task will be qualified. So you can see, okay, the ranking and the resolver engine has qualified, though both of them are possible matches. Then how did the ranking and the resolver engine, eliminate this task? So you can see like ranking and the resolver engine, depending on the similarity between the utterance of the user and the tasks which has qualified, has given an internal score. Here, open account task got an internal scoring depending on how many words out of the user utterance match with the label word and the position of the words in the utterance of the user. And this scoring came from how many, the similarity score between the user utterance and this FAQ. Now, after rescoring, you can see ranking and the resolver engine has given a higher score to this and a lower score to the open account. After that also, how did it eliminate this? If you come to the thresholds and configuration, and if you come to the ranking and the resolver engine, you can see that the proximity of probable matches has to be at 2%. That means the difference in the scoring of the two intents which are getting qualified as possible matches has to be within 2%. So it calculates 2 percentile of the highest score, and that 2 percentile is taken as the cutoff score, and any intent getting a score below that particular cutoff score will be eliminated by the ranking and the resolver engine. You can see this better if you are talking to the bot, and if I repeat the same question once again, okay, let's come to the NL analysis section. I'm directly going down to the FAQ, sorry, to the ranking and the resolver engine. You can see the cutoff score over here. So it calculates 2 percentile of the highest score, and the cutoff score is 12162.27. If you look into the score that was given to the open account task, okay, so if I come to the open account task, the score is 12410. Okay, so 1 second. Yeah. Let us see the final score. Okay. Yeah. So this was the cutoff score. So what happens is that you can see the score of this question was 12410. Whereas if you look into the score of open account, you will see it is below that. Okay, so 12410 was the thing. If you come to utterance testing and repeat the same question, you will see open account task is getting a score at 11,000 level. Okay, that is what we had seen. So it falls below that cutoff score. So that is why the task got eliminated. So after rescoring, whichever is the highest score, ranking and the resolver engine calculates 2 percentile of that and gets the cutoff score. Any intent which gets below that cutoff score is eliminated. If there are more than one intent getting a score within that particular cutoff score, then all the choices are presented to the user, allowing the user to select the one to proceed with. Okay, that cutoff score difference, that 2%, can be increased up till 20% by the developers. So you can come here and you can increase it up till 20%. So the range will go up, so more intents will get qualified. So if you want more suggestions to come up to the user, you can increase this up till 20%. Okay. Last example of this before we go to the batch testing. Let us see how do I open an account, how this is processed by the NLP engine. So once again, you can see the FAQ has been qualified. If you come here, once again, you see 2 percentile of this will be calculated, and that will be the cutoff score. This gets a score in 11,000. Of course, it will be below that cutoff score. So as a result, this is getting eliminated. Okay, so try out variations, see the scoring, go back and see it is 2 percentile by default. If you're changing it, see how the change is affecting. And then you can see the ranking and the resolver engine declaring the winning intent. Okay, is it clear to you all? Okay. But that should not be the only testing you do, because this is only with a few utterances which you are doing at the utterance testing level. But before you deploy the bot to the end users, you should do a very thorough testing of your bot. And for that, you should go in for a batch testing. So now for batch testing, you should have an input file, okay, where you can define all the utterances with which you want to test your bot, okay. Your file can be something like this, the structure of the file, where the first column is the input or the utterance with which you want to test your bot. The second column is the intent which should qualify. In case it is an FAQ, then put the primary FAQ that should qualify. And if you're testing for entity extraction as well, whether NLP is able to extract the entity value from the utterance of the user or not, then provide the name of the entity and the value to be extracted from the utterance and stored within this entity. If there are multiple entity values in the same utterance, then in that case, specify the entity names one after the other in different rows and specify the values to be picked up. Be careful about the name of the task and the entity name. If there is a mismatch, this file will not be uploaded into the bot. Okay, uploading this file is going to fail. Entity values are here within the test utterances. Entity names will come from the task, right? You have created these tasks within the bot. You should know that as a developer, you have to know the entity name. As a tester, you have to know the names of the entities which you have configured. These are the names. I guess this should be clear to you all by now. Okay, your almost 1.5 days training is done. So this is the name of the entity. The value of the entity is in the utterance. So when you look into the utterance, I want to open savings account with $1,000. Now this 1,000 is for what? It is the opening balance of the user. Okay, so the value is coming from the utterance itself. Which entity should pick up this particular value? The balance entity. The name will come from the task, how you have named the entity. So as a developer, you should be knowing that. Okay.
So one question here, Jayanti. My question was like, can we get this entity name and value from our talk to bot? That is when we are chatting with the bot, like from the debug logs.
When you're creating this test file.
Like I don't want to go into the dialog task and flows. So without going into my dialog tasks and flows, so can we get this entity name and value from the debug analysis only? I mean, from the talk
See,
to
the
bot?
value is coming from your test utterance. Okay, so value doesn't matter. It can be 1,000, it can be 2,000, it can be 500, as long as it matches with the entity type. Remember, if you are testing the bot, you should know about the configuration of your task. If you do not know anything about the configuration of the task, creating the test file will be difficult. Okay, you can get the name of the entity from your talk to the bot. Okay, so if I tell over here something like this, okay, if I'm putting something like this over here, I can see the name of the entity over here. I can see the name of the entity over here also. From this utterance, I can see savings has been picked up and stored over here. But how do I know what are the other possible values for this entity? Okay, what is the type of this entity? Unless and until I understand the configuration of the task or I see the configuration of that entity. So when you are creating a test file or when you are testing a particular bot, you should have a minimum understanding, or you should understand rather how the flow has been defined. Otherwise, testing the bot, understanding how to create that test file with intent identification testing and entity extraction testing will be very difficult. So you have to know, okay, that talk to the bot will not show you whether it is a list of items or whether it is a number or whether it is a person name, whether it is a date type of entity. Talk to bot will show you the name of the entity where the value is picked up. Okay, or if you're providing the value as an input also, while talking to the bot, the name of the entity, you can get it. But talk to the bot will not tell you the entity type. And unless and until you don't know the entity type, you cannot understand with what value to check for entity extraction, what kind of value you're going to use in your test file to check for entity extraction. Okay, did you get it? Did you understand what I'm saying?
Yes, Jayanti.
Okay.
One more thing, in the entity value, can we give dynamic values there, or we need to always give some static value only?
You cannot say over here variable X, okay? You cannot say that. You have to provide some value and see whether NLP is able to extract that value and store it over here or not. Okay. So that is how we test it. Okay. We want to put any value which matches with the type of the entity and finally check whether that value it can pick up and store it within the entity or not. Okay. I cannot say X over here. Somewhere I say X equal to number. That you cannot do it in a test file. Okay, test file is with test utterances. Test utterances should contain possible entity values to check for entity extraction and of course intent identification. Okay.
Yes.
Now, once you do that, create a file like this. You can have up till 20,000 test utterances into these files. And once you create a file like this, the next thing is to upload the file over here. Okay, so come to batch testing, click on new test suite, give a name to it, give relevant name. Okay, your description should be something like the date and the time or the name of the tester who is doing this test, something like that. And finally, you can either create this input file in the JSON format if you want to see the format of that file, how to create it, download the sample file, remove the dummy data and provide your own data over there. Similar with the CSV file, you can download the sample file, which will give you that structure, the column headers and all, remove the dummy data and provide your own data. Now, since my file is already created, so I just click on choose file over here, come to, I'm going to upload that particular file. So let me just quickly do it. And once the file has been uploaded, remember this upload will fail if your entity names do not match with the way the entities are named within the task, or if your intent names do not match with the task names. Okay, then the upload of the file will fail. It will show you the error message, what is mismatching, and click on create. So this will create the test suite for you. Okay, then come over here and click on run test suite. So that will start executing each of those utterances which are defined and generate a report on intent identification success, percentage and entity extraction success percentage. So you can see intent success percentage is at 73. Entity extraction is 67, we can say approximately. So that means there are some failures. Now let us download this report. When you see failures like this, download the report and see what has failed. Okay. So the initial part are the threshold configurations of each of these engines actually. And let's go in for the intent identification first, and then we will look into the entity extraction. So you can see the utterance over here in the details section. You can see the utterance over here, the expected intent, which was in the input file, okay, and the matched intent. The result type, you can either see TP, you can see FP, and at times you also get to see something called FN. Now, what are these parameters? Okay, TP implies true positive. Okay, that means the expected intent and the matched intent are the same. So for a given utterance, we were expecting this is the intent that it should match with. NLP, using the training, has actually qualified that intent. Since both of them are the same, that means it is a true positive. Okay. If you get a false positive, FP means a false positive. Okay. So false positive means the expected intent and the matched intent given utterance, we were expecting a particular intent to match from the bot, but the training that we had provided for the NLP engine has led the NLP engine to qualify another task incorrectly. So the expected intent and the actual matched intent are different. In that case, you get to see a false positive parameter coming up. Okay, the result type becomes false positive. And finally, you get FN, which stands for false negative. Okay, now false negative means we were expecting an intent to qualify, but we have not provided any training to the NLP engine to qualify the task. So intent identification has failed. NLP has not qualified any task for that particular utterance. So that there we say it is a false negative. No intent has been identified. You should look for FP and FN in your test result. Okay, those are the points where you have to find out what went wrong. Okay, so like, see, my brother needs money, urgently needs money. Make payment task was expected, but check balance task got qualified. Why did check balance task got qualified? By now you can understand the presence of the word money has led, ML engine to qualify the check balance task. That means we have not trained the NLP engine to qualify make payment task. If the user says, my brother urgently needs money. Okay, so if you come back to the bot, 1 second. This is how you should be testing. Either you can go to utterance testing and see which engine is qualifying the task incorrectly, why the expected task is not getting qualified, or you can talk to the bot also. Okay, put in your utterance over here. Okay, and see the NLP processing. So you can see the check balance task. If you come to the NL analysis, you can see ML has qualified check balance task. Once again, I hope you can understand the presence of word money is leading to that, but nowhere you can see the qualification of the make payment task. So that means very clearly we have not trained make payment task to handle this particular utterance. Okay, now what change can we do? Okay, we can come to the training and the best will be, to add an ML utterance. That should be the first approach always. But if you can, I can also use a pattern over here. Okay, so the utterance which has failed is my brother urgently needs money. Okay, so here I have money. Okay, needs or requires will be handled by any 3 words between the 2 words, but here I have only family. I don't have the word brother. So do I type in brother over here? But tomorrow an user can say my father needs money. Okay, so then do I come back and type in father? What will be a more efficient way? Okay, the best is I define a concept over here. So this is how you should be thinking, the most efficient way of handling these. So instead today the failure utterance has brother inside it. That does not mean always users will say brother. He can say father, he can say mother, he can say sister, he can say son, he can say daughter, whatever. Okay, so I can define a concept to handle all these family members. Okay, so what I do is I come to create a new concept. Let's say I create a concept called family members. And here within this concept, I put all the related family members. Okay, now once you do that, okay, now I'm going to use this concept within my, remember only defining the concept is not enough. You have to use that concept within the pattern. Okay, so I come to the pattern for this, and since I have a similar pattern, a small change in this pattern can handle that failure. That is why I'm using pattern, but remember pattern should be the last resort. Okay, try to handle failures through ML utterances always. Okay, so here I add that concept, and now let me just retry that failed utterance and see whether the task is getting qualified correctly or not. So this time the make payment task is getting qualified, and if you come here, you can see the FM engine will qualify the task as a definitive match because I have defined a pattern to handle that situation. Okay. So this is how you should be testing the bot, and your training should be driven by testing. Okay. Do a initial small amount of training to your NLP and then test the bot more. Okay. Try multiple different types of utterances and look into the failures where you are getting false positives, where you are getting false negatives, where intent identification is failing. Okay. And then, you can train your bot accordingly. Save money for emergency. Okay, so it is actually for open account check balance task is getting qualified. So what I do is I just go and quickly add an utterance over here. Let's say I just say save money. So if the user says save money or save cash, okay, something like that, then the task to be qualified is the open account. Okay, so once I have added this, if I try it, this time you will see using this particular training utterance, ML Engine will qualify the open account task. So these are the different ways in which you should be testing, and then to resolve the failures, first see whether you can make any changes in the existing training. But if any changes are not possible in the existing training, think of the most efficient training that you can provide to handle that particular failure. Okay, so now let me just pick this up and let us see whether open account task is getting qualified. You can rerun that test file also. Okay, after you handle all the failures, you can rerun it. Okay, or one by one, you just make changes and see whether the actual task is getting qualified or not. Okay, is it clear to you all how to look into the batch testing report, identify the failure scenarios and train it further? Any questions on that? Okay, now coming to the next part, which is the entity extraction. Okay, so go through all the other false positives and think of the ways to handle those failures. And now coming to the entity extraction, where you can see if entity extraction fails, you get false coming up in the entity result. Okay, like here in the result type, you get false positive or false negative. Similarly, if entity extraction fails, you get false coming up. So my utterance is, I want to make payment for purchases for $2,000, where $2,000, this value of 2,000 was the amount to be paid. So we have an entity called payment amount within this task. This variable should have, or this entity should have picked up the value of 2,000 from the utterance of the user, but we can see no value has been picked up. Why did this happen? Okay, it's a very interesting thing. Just see what is actually happening. Let us try this utterance first. What is happening to that 2,000? The 2,000 is there within my utterance. So why is it not picking up for the payment amount? Okay, you can see. Oh, 1 second. 1 second. Just give me a little second, because this training, I think, is already done. Just give me a second. I'm just going to make some changes here. I'll come to this. Actually, I imported this task from another bot of mine. So these failures were automatically, I had handled it over there in another session. So the training also got imported. So I'm just removing the training, because by default, these trainings won't be there. Okay. Now let us try it once again. So you can see what is happening is in the task configuration, there are two entities. Okay, one is the account ID, one is the payment amount. Both the types of the entities is what? Number. Okay, try to understand this very carefully, because if you are working as a tester or as a developer, you also need to test it, or as a business analyst also, you need to test the flows that has been configured. Entity extraction testing is one of the major part of testing your performance of the NLP. So if you see something like this happening, okay, there's a failure happening, there are certain things you need to understand, okay? So first is, in a task, you need to go and check out the entities and what are the types of the entities. You can see the type of these two entities are number. Now, the first entity that comes into the context after the task has been identified is the account ID entity. Okay, so this is the first entity that comes into the context. Now, the extraction logic of this entity is evaluate unused text from previous utterance. Now, from where you can see it, I'll show it to you in some time, but that is the default entity extraction logic. What does this mean? It means when the account ID entity is coming into the context, the NLP engine looks into this entire utterance that came from the user and checks whether there are any values that matches with the type of this entity. What is the type of this entity? It is a number. It goes through this entire utterance. It sees 2000 matches with the type of this entity. It picks it up, stores it into this entity. So you can see the bot did not prompt me for the account number because it has picked up the value of 2000 from the utterance and stored it within this particular entity. And what it does is internally, it marks this value within the utterance as used up. Okay, internally, it actually replaces it with the name of the entity. So when the next entity comes into the context, payment amount, this also has the same extraction logic because that is the default extraction logic for every entity. Once again, it looks into the entire utterance for some numeric value which has been unused, which has not already been used for some other entity. So it sees that the only numeric value which was there is used for account ID. So there's no other value in this particular utterance which can be used for the payment amount. So now what it is doing is it is prompting the user for the amount to transfer. So that is why, due to this extraction logic, the default extraction logic, and both the entities being of the same type, the first entity that comes into the context, which matches with the type of the input in the utterance of the user, picks up the value and stores it within itself. So the next entity for which the value was actually meant for, that entity, when it comes into the context, by that time, this value has been used up by some other entity. Okay, how do you see this extraction logic? If you come to any entity node that you have created, whether it is a number or a date or a string or a list of numbers, person name, whatever entity type you create over here, whenever it is an entity, if you come to the instance property of the entity, you can see the extraction logic, which is evaluate unused text from previous utterance. Okay, that is the logic which I explained right now. Is this logic clear to you all and what is happening for that particular utterance? Any questions on that? The other two extraction logic says, if you want to reuse the same value again and again for multiple entities of the same type within a given task, then you can go in for the second option. That is, it will reuse the same value again and again for multiple entities. It's very use case specific because usually we do not go in for this. If I enable this for this entity as well as for the next entity, you will see the value of 2000 is stored as the account ID as well as the payment amount. The same value will be used again and again if the value matches with the type of the entity within the same task. And the third one says, even if the utterance of the user contains that entity value, the NLP will not pick up the value from the utterance, rather it will prompt the user for the entity value. Okay, so it does not consider what the user has provided within the utterance, but when that entity comes into the context for which there is a matching value in the utterance, but in spite of that, bot will prompt the user for the entity value. Okay, so you can select the third option. But for me here, I wanted to extract from the utterance of the user, but I wanted to understand when to pick it up for account ID, when to pick it up for the payment amount. Okay, so the main challenge is because both the entities are of the same type. If the entities are of different types, this first extraction logic works fine. Okay, so you will see for the open account task, if I say something like, it is directly asking me for the balance. What happened to the previous two entities? Account type savings picked up from the utterance. Okay, for the account holder name Anna, which is a a proper noun, matches with the type of this entity picked up from the utterance. And finally, the balance is a entity for which there are no values in the utterance of the user, because this is a number. There are no numbers in this utterance, so the bot is prompting the user for the balance. Even if I put the balance over here, you will see the balance also picked up from the utterance of the user, and finally the conversation continues. So if all your entities are of different types, there is no challenge. The challenge is when both the entities are of the same type. How can you improve the understanding of NLP? This is where we come into patterns for entity extraction. So you have the patterns over here. Click on patterns for entity extraction. And here I'm going to add a pattern for extraction of the account ID from the utterance of the user. Now, when you are defining patterns for entity extraction, you have to provide the words or phrases that can come before or after the possible entity value within the utterance. Like, let's say, if you are mentioning the account ID, how do you mention it? I want to make payment from followed by my account number. So usually that word from is there before the account number. I can define a pattern for that. I can say from, and this asterisk marks a value that matches with the type of the entity. So after from, if there is any number, then this number should be used for the account ID entity from the utterance of the user. Press and enter. Or I can say account followed by an account number. Okay. Or I can say I want to make a payment using followed by my account number. You can have words before, you can have words after, you can have words before and after, and the value being between those two words. You can specify patterns in any way. But within the entity patterns, you have to have at least one asterisk over there mentioning that a value that matches with the type of the entity. So the word from followed by any number which matches, because this entity is of the numeric type, so any number, then this number will be used for account ID. Is it clear what these patterns mean? Any question on that?
Can we use, Jayanti, can we use masked numbers also here in our patterns?
Masked numbers
like for account number, even for account number, usually it shows XXX and it shows only the last 4 digits. So
that is data masking for security. Okay, this is training NLP to recognize the number. Now masking is only for visual, visually displaying it. Internally, the number will be stored as it is. This asterisk is for anything that matches with the type of the entity. Please understand the type of the entity. Again and again, I'm using this word, the type of the entity. What you are talking about is PII redaction of data, that after the user types in the account number, how the account number will be displayed back to the user. Okay, but whether the account number entered by the user is acceptable or not depends on the type of the entity. Got it?
Yeah,
is it clear to you? Okay.
Yes, ma'am. Yes, thank you.
So coming back to the payment amount, so in our utterance, we had the word worth followed by the numeric value, which was the amount the user wants to pay. Okay, think of all the possibilities. When you are training NLP, you have to think about the possibilities. Okay, so I can say I want to make a payment for 2000 rupees or something like that. Okay, so here I'm saying for followed by a number. Okay, so in this way, keep on defining as many patterns as possible to improve the intelligence of the NLP engine. And once you have defined the patterns, let us see whether NLP is able to extract, the values correctly or not using those patterns. Now, coming back to the same utterance which had failed, this time you can see it is prompting me for the account number. Unlike the last time where it had, directly jumped to the payment amount, asking me for the amount to transfer, this time it is asking me for the account number. And if I put the account number, now why didn't pick up 2000 though it matches with the type of this entity? Because the patterns did not match. Okay, there's the words like from or using or account is not present before this numeric value. So the patterns did not, qualify. And as a result, this value was not picked up for this particular entity. Now, if I put an account number over here, you can see it did not ask me for the amount to transfer because 2000 was picked up as the payment amount. The patterns worked because the word worth is there before this particular numeric value, which matches with one of the patterns that I have defined. So as a result, 2000 was picked up, stored into payment amount, and my conversation continued accordingly. So the extraction logic, along with that, if you see extraction logic is not good enough because you have multiple entities of the same type, then go ahead with defining patterns for entity extraction. Okay, and for entity patterns that you have defined, either you can come to each entity, go to the instance property and see the patterns, or you can come to the training section where you have a tab called entities, which will show you all the patterns that you have defined for that particular entity. And this entity is associated with these tasks. Okay, so you can click here and you can see all your patterns over here. You can add more patterns over here. If you want, you can remove these patterns as well. Okay, is it clear to you all? Okay, now once you have done all of these things, okay, your testing, your training and everything, I'll go back and I will just put in a welcome message today. Yesterday I had shown you all how to invoke a task, but today I'll just go in for a static message because I'm going to deploy the bot now. I can have that task also, okay, but I'm just changing it to something simple. Okay. Quickly, let me check whether my welcome message is coming as soon as I connect to the bot or not. Okay, so it is coming. So now I'm ready. I've trained NLP, I've tested it. I have the welcome message, everything. So now I go to deploy the bot and you can see the first tab is channels and all the possible channels that you can enable for the bot is coming up over here. Every channel comes with a very good step-by-step instructions on how to enable that channel. Please follow these steps if you want to enable this channel. Okay, but every channel will need you to have some access on the channel side also to do some configurations from the channel end. It's not a one-sided configuration, it is a two-way configuration. Okay, so you have to enable the channel on the bot. Similarly, on the channel side also, you have to put certain information related to the bot that you are deploying there. Okay, so it is a two-sided configuration. So the instructions will tell you for enabling the channel on the channel end, what are the access that you require and how to do the configuration at the channel end. Please follow all the instructions. Like here you can see you have to log into Cisco WebEx developer. There you say create an app, create a bot from the new app, and then you have to enable the bot over there. Okay, so for every channel you will see that. Okay, if you come to Google Chat, you will see you have to go to Google Developer Console and how you have to enable the bot at that end also, and you will get some data that has to be excuse me, from our end also. Okay, so those instructions will guide you through the process. Before you can publish the bot, at least one channel has to be enabled, but you can enable multiple channels if you want. Okay, just follow each and every channel will have all the steps given over here. Okay, so you don't have to go to the documentation for that. I'm quickly going to enable the web channel so that I can directly talk to the browser, to the bot from the browser. So for that, I go in for the web channel. Okay, now web channel does not have inbuilt instructions. So I'm going to discuss the instructions by one. Okay, now whenever you are accessing a bot from an external environment, okay, it can be from another channel, it can be directly from the browser, but it is not from within the bot builder. Okay, our platform will need an authorization. And that authorization is done using JWT or JSON Web Tokens. Okay. Now, how do you generate a JWT? You will need a client ID and secret for this bot to generate the JWT. And to get that client ID and secret, click on Create App. Okay. Give a name to your app. That name can be anything. It's up to you. But the JWT signing algorithm has to be HS256. Okay, click on create to create the app. So you can see a client ID and secret generated for my app. This is a unique ID and secret generated by the platform for my app. Along with that, you get to see the name of the bot and the ID of the bot. That's all you need to do. Just create an app which will give you a client ID and secret. So at the bot end, this is all that I'm doing to enable the web channel. Now, once the web channel has been added, if I want, I can add a few more channels. Okay, for that I'll need, access to those external channel side configuration also, which I don't have. So you all can try it out. Your enterprise will provide you those accesses. You as a developer, you may not have it. Okay. So whatever is the requirement, enable those channels for the bot. And once you enable the channels, go to publish. Here, when publishing, you can either publish all the tasks, okay, or you can just publish the tasks that you want, okay. Just forget this part because I had enabled multiple languages, okay. So just select the task that you would like to publish. Like, let's say I don't want the hello world task to be published. So I just deselect that particular task. Okay, so in this way, you can select or deselect whatever you don't want to publish or what you want to publish, and then click on proceed. Add a comment over here. Okay, so let's say this publish request actually goes to the admin of the platform for approval. So add a comment for the admin of the platform to understand what is the configuration that you're trying to publish. Click on confirm. So once the bot has been published, okay, so if you come to your dialog tasks once again, let me see why it is not getting published. So you can see these tasks has been published. Okay, the request for publishing these tasks, you get a message coming back from the admin of the platform that your tasks has been published. Okay, 1 second. Okay, so it is not published in some of the languages. That is why this part is not important for you all right now, because I have not gone in for enabling of multiple languages. So that is why it is showing me this message. But you will get the status coming up as published, okay, because only a single language is as of now enabled for the bot, and you have published your bot in that particular language. Now, once the bot has been published for the web channel, there are some additional configurations that you need to do. What are those? you need to download the SDK from our GitHub. Okay, so that link is there in the documentation that I have shared in yesterday's mail. Rather, in today's mail, you will see the web channel configuration. And once you go to that link and download the SDK from the GitHub, this is the folder that gets downloaded. Extract the content of this folder, and within this folder, you have all the configuration files. Go to SDK, go to UI, where you get all the files coming up. Open coreconfig.js file. Okay. Now, once you open that file, you need to put the details of the bot that you are publishing over here. So you can see the name of the bot, the ID of the bot, the client ID, and the client secret. So copy all these details from your channel. Okay, so if you come back to the channel, you can see the name of the bot. Copy this from here, put it over here. Copy the bot ID from here, put it over here. Copy the client secret, put it here where it is asking for the client secret. And copy the client ID, and copy the client secret and put it where it is asking for the client secret. So these are the details that you need to put in. Save this file with the new details. And before you can start talking to the bot, you have to start Node.js, which will generate the JWT. Okay, so all these you have to download Node.js, and also all the links are provided in that documentation file. Follow the steps given over there. Download Node.js and start Node.js within your local server or the server from where you're doing the deployment. And once you have started Node.js, now let us see whether we can connect to the bot directly from the browser or not. So all the steps which I have been talking about might be very confusing right now, but these steps are given, one by one in that documentation page. Just follow these steps over there to enable the channel. You need to download Node.js into your server, and you need to download that SDK from the GitHub. Enable the channel on the platform end, on the bot end. Provide the required details of the bot in coreconfig.js file. Start your Node.js server after that, and then directly connect to the bot. You can see I have connected to the bot. So here, if I say check my balance, it should trigger the task. Okay, let me put an account number. So what is a pre-approved car loan? Okay, so I'm just putting a few things so that I can show you all the analytics report. Okay. So something like this. Okay, so these can be conversations. Multiple users can have conversations from their browsers once they have the required configuration at their end. Actually, this is the website of the enterprise. So whenever a user connects, the bot is displayed and they can talk to the bot. Now, once the bot has been deployed, okay, you can follow the steps for each of the channel. Any questions on that?
One question is there.
Please go ahead.
Yeah, the one you're showing is the server side
Yeah.
one, right? Server side, both the UI and running in the same code. What if it's a client side code? So how can I able to implement
whichever
that
whichever server from where you are doing the deployment? Okay, if it is for a client, then from a client server you have to do the deployment. Okay, because whichever server you are doing the deployment, end users will connect. Now, this is the website of the, typically the web browser, that the web channel is used for the website of the enterprise. Okay, so this entire file, this entire configuration has to be done on the server from where you're doing the deployment. There's no server side or client side. Okay, end users are not going to do the deployment. End users will visit this particular website where they will get to see the bot and they'll just talk to the bot. So typically this channel is used for the website of an enterprise, where within the files, where the location, where you have those website deployment files, you should include all these files that you have downloaded and do the deployment from that particular server. So that when our clients are connecting through an URL to the website of the enterprise, the bot is also displayed within that particular website and end users can connect to it. Okay, please try to understand that. You are not going to go and sit and deploy the bot at millions of users server end. Okay, this is not how it works. It is from the server to which end users will connect. What is the medium of connecting? It can be the website of the enterprise to which the end users are connecting using an URL that they have access to. Okay, or it can be Facebook Messenger or something like that. Look into the instructions how to enable it. So that will give you a particular ID with which you can connect to the bot as an end user. Okay, that is how it works. You are not going to sit and deploy the bot for individual end users at their machine end or at their system end. It doesn't work like that. From a server, you are going to deploy the bot to all the end users who can access the bot whenever they visit that particular server. Okay.
Okay. Yeah.
Now, once you come to the analyze sections, once you deploy the bot quickly, the most important report which will help you as a developer to understand the performance of the bot after it has been deployed is the NLP metrics report. This will show you 4 tabs. The first tab is intent found, which will show you all the utterances and which intent got qualified correctly. Okay, so you can see the utterance and the FAQ or the intent which got qualified. Okay, if you want to see the details of the conversation, you can click on it. It will show you which channel was used, what was the intent that got qualified. If you want to see the NLP scoring and all, you can click on show JSON to see entire scoring. If you come to NLP analysis, you can see the summarized view where you can see the fundamental meaning engine had qualified the task as a definitive match. So finally ranking and the resolver engine declared that as the winning intent. And you can see the chat history. As a developer, you can see, now remember these analytics report are not for the developers. This is the configuration, and try to understand the difference. You know, many a time you get confused that as an end user, I can see this. No, end users are people who are just talking to the bot. These are for developers to understand the performance of the bot at the back end. Okay. So here you can see the chat history, how the conversation continued after the intent was identified. Okay, so you can click on any one of these utterances and see the processing of that and how the conversation continued with the bot after that by the end user. The next tab that you have over here is intent not found, which will show you all the utterances which led to intent identification failure. Okay, so the user had provided an utterance but no intent was qualified. Okay, maybe it had happened earlier. You have trained NLP now, so if you want to see that, you can see it over here now. Okay, so there was an intent, failure. What is a pre-approved loan? I have made those terms mandatory now: car loan, home loan. So this will not lead to qualification of any intent. The FAQ identification will fail. So in chat history, you can see how it had failed. Okay, the response of the bot, you can come to NLP analysis and you can see no FAQs got qualified. Okay, if multiple intents are getting qualified, that is also taken as a failure on our part. You can see it as an ambiguous intent identification. Okay, So anything that is not identified will be represented under intent not found. So these are the failures. You can look into the failures, try to identify why it failed, talk to the bot, see how the NLP engines fail to qualify the intent, think of ways to handle it, either by training the ML engine. That should be the first approach. If it is a failure in identification of a dialogue task, or if it is an FAQ, think of the ways you can improve the training of the KG so that the FAQ is identified correctly. Okay. Failed task will show you you can insert a link in the bot response. Okay. So any response, it can be a message in a dialogue task, it can be an FAQ response. You will see an option, insert link, in that formatting section where you can insert a link, and clicking on that link, the user can go to a particular website. It can be a part of the bot response. Okay. Coming to failed task, it will show you all the utterances where a task was qualified, but the user did not complete the task. Okay. I'll just show it to you if I have time, from where you can. I had shown it yesterday also, but I'll repeat it if possible today. Okay. So you can see the reason of failure coming up. Maybe the conversation window was closed, or maybe another task was initiated while the user was within one particular task, or the user did not provide the expected input within the number of retries. The task was discarded. So multiple reasons why the user had not completed the task, and you can see the failure reason coming up with the name of the task. And finally, the performance tab, which will show you the time taken by the API calls to return the response, or the time taken to execute a script node. Okay. For an API call, many a time, if the task comes to an end immediately, we cannot see the response of that API when we are talking to the bot. But you can come here, go to that API call, and this will show you the response that was returned. Okay, so you can see this was the response that was returned by this specific fetch balance API call. Okay, so many a time this is required. You want to see what was actually returned. If a script node fails, okay, due to some error in JavaScript, maybe your debug window is not showing you the exact reason, come to debug logs over here, and you will get to see the error message coming up why your script node has failed. I guess these are certain things I have already discussed in yesterday's training. Okay, so we are almost towards the end. Let me complete the pending topics first. But these are topics I have discussed in yesterday's training. Please refer to it. Okay. Okay. The other report which we can use, okay, is the usage metrics, which will show the real-time status of a bot. Okay, so how many users are currently connected, what are the channels they can use, they are using in order to talk to the bot, how many tasks they have requested for. If you want to see the total number of messages, date-wise exchange between the user and the bot, you can see it from here. Total number of messages and sessions taking place between the user and the bot, how many FAQs and how many tasks were completed by the users on a given date. Okay, so you can see it, 2 FAQs and 1 task today. If there are failures in intent identification, it will be represented as a percentage within this particular pie chart, and how many times each task or each different tasks were requested by the different users, the total count of that. Okay, right now I have just have one conversation where I have requested for different tasks once only, but if I repeat it, you will see the count increasing over here. And total number of messages exchanged between the bot and the user on a particular channel. This gives you the real-time status, and this usage metrics will only show you report after the bot has been deployed and end users are connected to the bot. Whereas the NLP metric shows you both talk to the bot, utterances, as well as end user utterances. If you just want to see the end user utterances, come here and exclude the developer utterances. By default, the developer utterances are included, but you can exclude it just to see the end user utterances. You can also filter on date, on language, on channel, on a particular task. You can apply a lot of filter to refine this particular report that has been generated. And each of these reports in NLP metrics can always be downloaded to be shared with your co-developers. Okay. Any questions on the analyze part on the two reports that we have discussed? Okay. Now coming to how to share bot with your co-developers. Yesterday I have said, first you need to invite your developer to your account from your home page. And once you do that, come here, click on invite and provide the name of the developer. This developer has first to be invited into your account for your home page. Okay, select that developer, select the role. The developer roles gives entire access to the configuration of the bot. The concerned developer can make any changes in the bot configuration. The tester role only gives a view access. He or she cannot make any changes to the task configurations, okay, or any configuration, NLP configuration, FAQ configurations, task configurations. He can just see it, but not make any changes. These two roles are available out of the box. Additional rules can be defined by the admin of the platform. And then as the owner of the bot who has created this bot, you can use this role to share the bot with your co-developers. Co-developers cannot share the bot further with anybody else. This is a privilege only given to the owner of the bot. In this way, you can share your bot with your multiple co-developers and assign different access roles to them. Any questions on this? If you want to take your bot from one system to another, maybe you are building your bot in your development environment and then you want to take it to your deployment environment, then come to bot management under deploy. And here you have import export. Okay, so go to export. Okay, do you want the published version? Or after publishing the bot, if you have made changes to the task configurations and all, you can click on the latest version. And there again, you can select what you want to export from your bot. Click on export. This will download a zipped file within your system. Okay, wherever you are building your bot, a zipped file gets downloaded over there. Go to this particular zipped folder. Before you copy it to your destination, just extract the content of this and see that these three files are inside it. The definition file, the config file, and the icon file. It is mandatory all these three files are there. If any one of the file is missing, your export has not taken place successfully. So re-export it once again. Then copy, once you see that, you can copy that zip folder from your system to your destination or wherever to other server. And there to build a new bot with the export that you have given or you have over there. First, extract the content over there. Click on new bot over here and say import a bot. Give a name to your bot. Okay. And select your definition file. Click on import. So that starts importing the configuration from that export file and create a new bot with this particular name, which will have the same configuration that you have exported. Okay, let the import complete. And then we will see the configuration of this new bot. So now if I come to the summary page, you will see the same task configurations, FAQs, the same number of questions and answers over here. My small talk, my custom small talk, greetings. You can see my digital form. You can see all the patterns, the number of patterns and these things. If I go to this, it will show me the details. The only thing that is not exported is the channels. Channels are not a part of the export. It has to be enabled separately for every bot that you build. Okay, so even if you're importing configurations from an existing bot, you need to enable the channel for the bot before you deploy the bot to the end user. Is it clear, the import-export part? You can also import into an existing bot. So maybe your knowledge graph has been created by somebody else, and now you want the knowledge graph within your current bot. So you can come to deploy. I'll just take 10 more minutes to complete. If you have a hard stop, you can drop off. You will get the recording of the session. You can follow it from there. So if you come here and you come to bot management, you have import here. Select your definition file and config file, but be careful. If you have full import selected, the configuration that you're importing will replace the entire existing configuration of the bot. If you just want to import some selective things from your export file, then go in for incremental import and select the task that you would like to import. So if you just want to import your knowledge graph, then deselect everything else and just have knowledge graph enabled. So that will only import the knowledge graph from the export file. So be careful when you're importing within a bot. Full import, once again, I'm repeating, will replace any existing configuration within this particular bot with the new configuration that you are importing. Any questions on import and export? Okay. Coming to bot versions, you can create versions of your existing configuration. So within a particular version, you can click on new version, give a name to your version, and in the description, you should have a detailed description of the configuration of the bot, which is stored under this particular version. The purpose of creating a version is tomorrow, let's say today you have a very good working configuration, but tomorrow you need to make some changes in this particular configuration. Like let's say I come to the make payment task, and here, let me just quickly show you all how to invoke another task from the current task. So at the end of the make payment task, I want to invoke the check balance task so that automatically the user is forced to check his balance after he makes a payment from his account. Okay, so how do I invoke the check balance task from the make payment task? So I am making a change in the task configuration. Before this change, I have created a version. Okay, so I come here and I go to dialog task. Okay, this will immediately list out all the tasks which are available, okay, which are already configured. Select the task that you would like to invoke from your current task. Yeah, sure. Please go ahead. I have just one small little topic. You can follow it up from the training, from the recording. Okay, so just invoke it from here. So what will happen at the end of the make payment task, you will see the check balance task is automatically initiated. Okay. There were two other questions regarding how to insert links and all. So if you come to a message node, you can come to manage responses. When you look into the response, you can see you can insert a link. Okay, you can insert images within your responses. The same thing applies for KG questions also. When you are in the response of a KG question, okay, so there also in the response section on the formatting, you will see the option to insert a link or image as a response of your KG question. Okay, clear? So here you get all the options, that is inserting a link or inserting an image. Okay. So once you make the changes and all, you test your bot and you are not happy with the changes, you want to revert to your previous configuration. Okay, so the configuration that you have saved under a given version. How do you do it? Come back to that version, click on the three ellipses and say restore. So whatever was the configuration of the bot that you have saved under this particular version, that will be restored. So any changes after that will be cancelled. Okay, it's a very good way of, if you have a very good working configuration and tomorrow you're making some changes into it, because you cannot, just say undo or control, X is not available to undo your changes. create a version with the existing configuration before you start making the changes. So that if you want to cancel the change, all the changes, all you need to do is to restore that version. So you can see my sub dialog node has been removed from this task. Okay, is it clear to you all the purpose of versions? You can create 20 separate versions like that, and you can revert into any one of those versions. And whenever a bot is published, an auto-created version is generated by the platform with the configuration that you're publishing. You can revert to any published version of the bot as well. Okay, and finally, you can delete a bot as long as you have not published it. But once a bot is published, if you click on delete, the platform will not allow you to delete it unless and until the admin of the platform suspends the bot, and then only you can delete the bot as an owner of the bot. Okay, so the owner of the bot has two special privileges over the co-developers. One is he can share his bot with other developers, and the second is he can delete the bot. These are two things which we reserve only for the owner of the bot. No other person, even if he has access to the bot as a co-developer, cannot do these two things on the configuration of the bot. Any questions on anything that we have discussed in this training session? Okay, so I'll be sharing the recording with all of y'all, just like today. I'll be sharing it tomorrow also. If I have missed out any one of y'all today, I'm repeating once again, please drop me a mail so that I can include you in the mailing list tomorrow. It is very important because you will not be certified unless and until you complete the post-training assignment. Okay. So after I share the recording tomorrow by day end, I'll be sharing the assignment individually with you all. Please complete that assignment. It is a bot building exercise. Just like I have built a bot in the training session, in the similar fashion, you will be assigned a use case. You have to build a similar bot as per the use case that has been assigned to you. It will cover whatever we have discussed in this training session. Okay, if you have any challenges with JavaScripts and all which is required in that particular use case, please drop me a mail. Otherwise, if you cannot understand anything or how to implement a particular configuration, always revert with a mail. I'll be responding back within a day. And once you complete the configuration, we give you 2 weeks to work on it. Once you complete the configuration, export the bot and attach that zip folder in your mail and mail it back to me. We are going to check your configuration, and if you have completed the configurations as per the requirement, you will receive the completion certificate, and then only you can register for the advanced training session. Okay, any questions on that? Yeah, this is my mail ID. Okay. See, if you have not received yesterday's training, I guess you have not received it because I did not get your email ID. Please drop me a mail. Okay, so if you have not received it, send me a mail at this particular mail ID so that I can share, tomorrow I can share the recording. I'll be sharing the link once again for yesterday's recording also. Okay. So thanks all of you all for joining the session. Anywhere, any questions, feel free to drop me mails. Okay, with your questions, complete your assignment, you will be certified, and then I'll talk to you all in the advanced training session.
Thank you.
Thank you.